Well, welcome to our Matthew C. Algebra 1 DVD. I have with me today several lovely students and their parents and my sons who are filming this. And we're going to be doing Algebra 1, but a little bit of introduction is needed before we do too much. The first thing I want to encourage you is to make sure that you have your basics down before you even start this class. When I mean basics, I mean adding, subtracting, multiplying, dividing should be down cold. Fractions, decimals, and percents, that you should know those without having to hesitate. And so what I'm saying is you should have gone through pre-algebra before you do this class. Now, to make sure of this, we have a pre-test either on the web or in the book. Take the pre-test first. If you ace it, then you're ready to go. If you don't get it, then please go back and shore up your foundation. Now, I used to be a high school math teacher. My name is Steve Demme, which I didn't tell you, but you probably knew. And some of you who have watched me before are probably wondering, why do I have no hair? Do you know where my hair went? You think it was just age? Or I was at a camp a couple summers ago, at a Johnny and Friends camp, and they shaved my head to raise money for the recreation fund. And then my wife said she likes it. So that's why I no longer have any hair. Happy wife, happy life. Do you agree with that? All the ladies are smiling. But anyway, so if I don't want to shock you too much if you've been watching me before. But the thing is that math is a sequential subject, and you really build upon things that you've learned previously. So if you have any gaps in your knowledge, it usually catches up when you start doing the upper level math. Now, for example, I used to be a high school math teacher, and I taught everything from the advanced math classes down to algebra, geometry, etc. Oftentimes, it wasn't the algebra that gave kids the hard time. It was the fact that they didn't really understand fractions or their multiplication facts. Those were the two main culprits. So if you're still doing your facts on your fingers, stop and go back and get that down cold. If you're still a little shaky in fractions, reinforce that, because we're going to be assuming that those things are part of your repertoire, that you really are comfortable using fractions, decimals, percents, and all your basic operations, okay? Now, I have a little equation here. This is the first equation you're going to see today. So help me and help the people that are watching this, all right? What do you think the MUS stands for? Math UC. Very good. What do you think the D, T, and B stand for? That's a little trickier. If you use the DVD properly, and if you use the teacher instruction manual, and if you use the blocks, that's the nice word for manipulatives, then you'll have a happy experience with Math UC. But let's say that you really like to watch the DVD, but you don't want to read the teacher instruction manual, which has lots of examples. It has the answer keys. It has tips that I've learned after I filmed the DVDs. But you like to use the blocks. Or let's say you like to watch the DVD, but you don't really want to read the instructions and you're too big for the blocks. I have heard that. I am very large and I still like the blocks. So you never really outgrow the blocks. And if you give them a chance, and it's one thing to watch me doing it, another thing to watch and do them yourself on a table. So we don't use the blocks near as much in algebra as in other books, but we still use them, okay? Or what do you think this means then? You don't want to watch the DVD. You don't like bald guys. I don't know. Maybe that's the thing. But you like the book. And some people would rather read the instructions than to watch them. Some would rather watch them than read them, but you really need to do both. So I'm encouraging you to do both. So let's say that you leave out some components. What do you think MUAS stands for? Well, what's the M? Math. U. Almost saw. Okay? So in order to use Math UC, you want to use all the components of the program. And so we're going to use as much of your brain as we can. So whenever possible, I'm going to be building it, I'm going to write it, I'm going to say it, you're going to hear it, you're going to write it, and we're going to use all the sensory applications that we can. That's a fancy word. It's called multisensory teaching, okay? Now, beyond the DVD and the instruction manual and the blocks, in your student book, you have 2 practice pages, and we're putting all the time more on the web. So if you need more practice sheets, check with the web frequently to see. 2 practice sheets, and that's just focusing on the new topic that we're going to teach. Then you have 3 systematic review pages. Usually we recommend you do most of those, because there's all kinds of stuff in there. There's some quick review from previous lessons. Do the review pages. They teach the new stuff plus everything you've had up to that point. Who likes the word cumulative? Yeah, very good. The parents raised their hand and one student. So cumulative means we're going to keep doing stuff so you don't forget it. We're not just going to do one thing at a time. We are, but we want also not to lose the stuff you've already been taught. Okay? Now, we also have some new things added now. We have honors sheets. Now, honors is like challenge work. It's enrichment. It's extra credit. When I was in school, that's a long time ago, we had extra credit problems, but it's a little bit more. And if you're going to be doing any kind of a career with math or science or upper level science classes, we recommend that you take the honors sheets. But you don't have to complete a lesson to learn the material. And then you have a test. If you ace the test, after you've studied lesson 7, for example, and you go all the way through and you take the test and then you get a perfect score or pretty close to perfect, you're ready to move to the next lesson. If you mess up, I shouldn't say mess up, if you have difficulty with that lesson, the test will show that. And then you want to go back and do an extra worksheet or spend some time, because I'm assuming that you've really learned lesson 6 when I teach lesson 7. Okay? Now, who can do that? Anybody can do it. Don't feel like you have to keep going through the book. Have some courage. If you don't get something, go back and master it until you do. It's a difference between tutoring and teaching. When I was a classroom teacher, I had to move at the textbook's pace to finish the textbook in a year. Well, let me ask you this question. How long will it take you to do a lesson in Matthew C? What do you think? As long as it takes you. Very good. Because sometimes you'll get a lesson in 3 days, and you might do a couple worksheets a day, and you say, I really like this, and I get it, and you're ready to go. You might do 2 lessons in a week. Another lesson, you might take 2 weeks for just that one lesson because you worked at it and you're just not getting it. Take your time. There's nothing that Moses ever wrote in the Bible that says you have to finish a lesson in a certain amount of time. All right? Is that okay? All right. Now, if you struggle and you need a little bit of help, then you can email us at the headquarters, call our customer service reps. You can go on the users group, you can ask questions. We have tutors online. Sometimes you can even get to me. You can send an email and we'll try to help you through it, okay? So don't hesitate. If you're having a difficult time with something, just call and we'll see what we can do. All right, so now let's start lesson 1. You guys like to play hangman? Do you? You want to play hangman for the first lesson just so we can get warmed up here? Okay, you know how I play it though? We use our blocks, so maybe we call this block man, okay? So what we're going to do is we're going to make a little hangman, and here's the word. Boy, it's taking too much of the board. Let's move the hangman down. Okay, so how many pieces of the hangman do you want? What do you think? Head? Okay, so here will be the guy's head, and then this will be the guy's body, and this will be his 2 arms, and these will be his 2 legs. Okay, he's a long-legged guy. Now this is all you get. So you get 1, 2, 3, 4, 5 guesses, and then we're out of here. Okay, so let's try it. Who wants to go first? You get to guess a letter. Let me make sure I got it right. See? That's it. All right, you ready? Go ahead.
You get 6 guesses.
6 guesses. Why is that?
There's 2 legs, 2 arms, a body.
All right, you get 6. Thank you very much. This is Matthew. See, we make sure we count properly. That's good. Okay, so who wants to go first? Give me a letter. A. Very good. Yes. C.
M.
Ooh, that's a good one. This poor guy's not going to have. Somebody else over here. Go ahead, pick a letter, any letter.
O.
Oh. Goodness gracious. Did you hear me say the word or something? You're reading the notes? What? Keep going. U. This is the most discouraging hangman experience I've ever had.
L.
L, finally we get to have a guy. Okay, there's no L's, okay. Yes,
N.
good. Okay, I mean, oh dear. Who said T? Okay, very good. E? I. Okay, you rescued the man before he's dead. Okay, very good. So the word is, how do you say the word? Commutative. Now, some people like to say commutative, but it's not commutative. And the key word here is commute. Now, does anybody here have a parent that drives to work? How far is it of a drive for your dad to go to work?
Half an hour.
Okay, so let's say he drives 20 miles to work. When he goes to work, it's 20 miles. How many miles is it when he comes home?
40 miles.
Total for the day, yeah, but it's 20 miles this way and 20 miles this way, right? Is one of them a positive 25 and one of them a negative 25? Or 20? They're both 20 miles, right? Okay. So the commutative property means that no matter which direction you're going, it's the same. So, for example, if you had 5 plus 7, is that the same as 7 plus 5? What's 5 plus 7, everybody? 12. What's 7 plus 5? 12. So that's commutative. So addition is commutative. What if we had 5 times 7 and 7 times 5? Is that equal? Okay, what's 5 times 7? 35. What's 7 times 5? 35. Okay, so multiplication is commutative. How about this? 5 plus 7, 5 minus 7 and 7 minus 5. What's 7 minus 5?
2.
What's 5 minus 7? Negative 2. So they're not the same, so this is not commutative. Subtraction, okay? How about this one? What's 5 divided by 7? Well, it's just 5 divided by 7. It's 5/7, right? And then if you had 7 divided by 5, that'd be 7 divided by 5. Is 5/7 the same as 7/5? No, so division is not commutative. All right? Now let's try some associative. And I'm just going to give you that word because you guys are too good at hangman. Associative. So let me write some problems up here. 3 plus 5 plus 7. Associative, when I think of associative, I think of who you associate with. Do you have your favorite friends? Have your buds? Yes or no? Certain kids? Okay. Do they ever change? Are any of you ever a part of like 3 friends that sometimes 2 of you are pretty close and then sometimes you're on the outside and then the next time you're in the inside and they're on the outside? Do you ever have that happen? No? Where have you been? Yes, this always happens. Okay. So associative is the parentheses. So let's say that 3 and 5 are buddies today, but 7's kind of on the outs. But then tomorrow, 3's on the outs, but 5 and 7 are on, they're close, okay? Does this work? What's 3 plus 5?
8.
8 plus 7 is 15, okay? What's 7 plus 5?
12.
Plus 3?
15.
Okay, so addition is associative. Got that? Okay, now we'll try one with multiplication. We're going to associate the 4 and the 5, and here the 5 and the 6. Let's see how that works. What's 4 times 5?
20.
20 times 6 is 120. Good. Okay, what's 5 times 6? 30. 30 times 4? 120. So multiplication and addition are no problem. They're associative, okay? Now let's try some subtraction. And let's see how this works. 10 minus 7 minus 4. And these 2 are buds today, and these 2 are buds today. What's 10 minus 7? 3. 3 minus 4. Okay. Parentheses first. What's 7 minus 4?
3.
And what's 10 minus 3?
-7.
Does that work? No. So subtraction is not associative. Okay, let's try division. 8 divided by 4 divided by 2. 8 divided by 4 divided by 2. Where do you think I'd put the little parentheses to tell who's associating with each other? What do you think first?
The 8 and the 4.
8 and a 4?
And then the 4 and the 2.
Okay, let's try this problem. What's 8 divided by 4? 2. And what's 2 divided by 2?
1.
Good. Now, what's 4 divided by 2? 2. What's 8 divided by 2?
4.
Are they the same? No. Okay, so division and subtraction are not associative or commutative, okay, but adding and multiplying are both. Okay with that? All right. Remember I told you before that math is sequential? You know what that word means? What do you think sequential means? Usually you learn it in a certain sequence. So the 4 levels of math, which I think need to be taught sequentially, are, at the very essence, math is counting. Okay? This is level 1. Level 2, adding and subtracting. Subtracting is the inverse of adding. Inverse is like a fancy word for opposite. Okay? It's a math word. Now, these are related, though, because you could say fast counting. For example, how many people are at this table, how many people at this table? Well, I could count them, go 1, 2, 3, 4, 5. Or I could say 3 plus 2 is the same as 5, right? So in a sense, fast counting is adding, all right? Now, if I had 50 tables and there's 3 people at each table, I could say, well, I could go 3 plus 3 is 6 plus 3 is 9. Or I could just say 3 times 50, right? And so fast adding of the same number is multiplying. And fast subtracting is dividing, okay? Now, what's fast multiplying of the same number? Like 3 times 3 times 3 times 3. How would you write that? 3 to the 4th power, right? So that's an exponent, or powers. And the opposite of finding a power is finding a root, like squares, square roots, cubes, cube roots. That make sense? Okay, now the reason I tell you this is I'm always looking for order. Really, I do. I think that math is one of the few subjects where things all usually make sense once you understand how the order and how it's affected. But what we're going to study now is how to do the order of operations, so that if you get a problem like this, let's say you have 4 times 3 in parentheses plus 4 squared minus 6. What are you going to do first? How do you know to do the parentheses? Okay, so what we're going to do is we're going to talk about a way for you, when you see a problem like this, a strategy, but it's based on these 4 sequences, okay? It's the reverse. You do the exponents and roots and parentheses first, and then you do the multiplying and dividing second, then you do the adding and subtracting third. So it's an inverse of the 4 steps of mathematics, okay? Now, how do you remember that? There's a couple different ways, because you want to think parentheses, and you want to think exponents, and then multiply and divide, and then you want to add and subtract. So there's a couple different ways. Usually what I think of is parachute expert, my dear Aunt Sally. That's what I've said for years. Then the other day I was at a conference, because I'm always learning new things, and some students told me, oh no, here's the way we remember it. Please, P for parentheses, please excuse my dear Aunt Sally. Maybe she burped. I don't know. Okay, so you get that? So whichever one you want to do, parachute expert or please excuse my dear Aunt Sally, is how we're going to go through the problems, all right? So in this particular problem, where's the parentheses? So what's 4 times 3? 12. And then we're going to do the exponents as well. What's 4 squared? 16 minus 6. There's no multiplying to be done now, right? So there's no multiplying, dividing, but we have adding and subtracting. When you have adding and subtracting in the same line, we're just going to go left to right, okay? So what's 12 plus 16?
28.
28 minus 6? 22, and that'd be your answer, okay? Can you think of a different way besides parachute expert, my dear Aunt Sally? Okay? You okay? Let's try one more. Let's say that we had how you like that problem? Do we have any parachutes? No parentheses. Do we have any exponents? No. Have multiplying? No. Now what are we going to do, though, to attack this problem a little bit different? What would you suggest? If you were going to do this problem, what would you do first? Yes?
Add the A's together.
Let's get all the A's together and all the numbers together, okay? So here we have a 5A and a 4A, okay, and a minus A. So it's 5A plus 4A. Minus A? 8A. But we could write it all out if we want. 4A minus A, and we can even use some parentheses. And then we're going to put down the numbers. What we have? We have a 3 plus a 2, and the sign goes with the number, minus a 5 plus a 1. All right? So we already figured this out was 9 minus A, so it's 8A. Then we have 3 plus 2 is what?
5.
Minus 5? 0 plus 1? So that's the answer, okay? Now can we add 8A plus 1?
No.
How come?
One has no A at the end.
Yeah, they're not the same kind. Now I'm going to tell you this probably in another lesson, but I'm going to tell you now too. One of the key concepts that normally we don't teach till algebra, but it should be taught way back in teaching adding and subtracting is you can't add two things unless they're the same value. All right? I'll give you an example. What's 2 hundreds plus 300? 500. I will tell you when they get tricky. That was not a tricky question, okay? Now we'll try another one. What's 4 tens plus 1 10? 5 tens. What's 400, it's a little trickier now, plus 3 tens? 400s plus 3 tens. It's 400 plus 3 tens, right? It's 430 because you can't combine the hundreds and the tens. They're not the same kind. I'll try this one. What's 2 nickels plus 5 nickels? 7 nickels. What's 2 nickels plus 3 dimes? 2 nickels and 3 dimes. Now, if you want to combine them, though, how could you do it? You could make them both pennies. So 2 nickels would be how many pennies? 10. And then 3 dimes would be 30. What's 10 plus 30? 40 pennies or 40 cents. Does that make sense? That's right. You're supposed to laugh at the jokes so everybody at home gets them. Okay. So, well, how about 3 apples plus 2 peaches? 3 apples plus 2 peaches, right. So what's 2 x's plus 1a? 2 x's plus 1a. Very good. So in this case, we have a's plus a number. So we just have to leave it just like this. All right. Now, sometimes you're going to see a symbol that looks like this. What do you think that is? You ever seen that? How about this? It means absolute value, and it makes whatever is inside positive. So what's the absolute value of negative 3? 3. What's the absolute value of positive 3? 3. Okay. But when you're in order of operations, you treat the two absolute value bars as a parenthesis. All right? So when you're doing these and you see absolute value, you think, oh, that's just like a parenthesis. So we do that at the end or the beginning? Beginning, because, and how do you want to do it? Who likes the parachute expert? Okay, who likes the please excuse my dear Aunt Sally? All right? Choose whichever one works for you. What do you call that? Tell me what you think that is. It's an equation. Where's the word equation come from? Do you ever think about stuff like that? I think about it all the time. When I go to a town, I try to figure out why the town is named that, or why, streets are named the way they're named and things. So this morning we were coming down in the car and we were talking about journal. It comes from jour, J-O-U-R, which I think in French is day. So it's like your day guide, right? Your journal. So equation has what word in it that looks like one of these up here? Equal, right. It's an equal sign. It means this is the same as this. Now, we hardly ever use the word equal or equation in real life. So oftentimes I'll say same. X is the same as 2, right? Or X equals 2. So most of the time when you're in algebra, you have these big complex equations and you whittle them all down, and that's what the last step usually looks like. So I'm going to do something a little different just to help us to understand how we can do that. Now, do you think if I was to start with something like this, 3 equals 3, is that okay? That's an equation. If I added 5 to both sides, is that okay? 8 equals 8, is that still an equation? The sides both the same? Okay. So as long as you add the same thing to each side, then you're okay. And you can think of it almost this as a fulcrum. You know what a fulcrum is? A teeter-totter. Oh, see, a teeter-totter. So if you're at the local park and you have this line that's equally balanced, and let's say that I'm on one side and my twin is on the other side, as long as you two guys each get on the same time, and then you, see what I mean? So as long as we keep adding the same amount, we keep it balanced, right? Okay, so what if I was to add to this, add another x? Can I do that? Still an equation? So now we have 2x over here, and we have x plus 2 over there, right? Is that okay? So what if I was to add 3 to both sides now? Then I'd have 2x plus 3, and what would this be? Well, I could put x plus 5, or I could put x plus 2 plus 3. Could I add anything else to both sides? As long as I add the same thing to both sides, so let's say I'm going to add 2x now to both sides. So now I'm going to have 2x plus 3 equals x plus 2 plus 3 plus 2x. Can I keep going? How about if I subtract 1 from both sides now? How about if I subtract another x from both sides? Is still okay? Okay. As long as I keep doing the same operation to both sides, I still have an equation. Now, let's go backwards. Remember what we did in the last lesson? What if we wanted to simplify this now and make it down into something like this? What's the first thing we should do? To compare or combine, you must be the same kind, right? So to compare or combine, compare means less than or greater than or equal, and combine means to add or subtract. Let's get everything that's the same kind. Let's get all the x's over here, and we have negative x plus 2x plus 2x, okay? And then we have a 3 and a minus 1, plus 3 minus 1, so we can put that in here like that. What do we have over here? X plus 2x minus x, and then we have 2 plus 3 minus 1. Okay? Now let's smush them all together. What's 2x plus 2x? Minus x. 3x plus 2, and then we get over here, we have what? X minus x is 0, so we have 2x, and we have 2 plus 3 is 5, minus 1 is 4, right? Okay, now what are we going to do when we get this far? I really want to get it real simple. I want to have x equals something, but I have 2 x's on this side, and I have 3 x's over here. If I can add the same amount to both sides, can I subtract the same amount from both sides? As long as I do the same thing to both sides. So I'm going to subtract 2x from both sides. And now I have x over here, and this is 0. Then I'm going to subtract 2 from both sides, and now I have x equals 2. Does that make sense? So as long as I'm adding or subtracting the same thing from both sides, I can keep doing that. How many of you have ever done problems like this already? Okay, you should have had a little bit of this in pre-algebra and some of the other classes you've had at this point. But if you haven't, Just remember, as long as you do the same thing to both sides, you're good. Now, can anybody tell me that that sentence one more time that I said? You finish it. To compare or combine must be the same kind. And the same kind means the same value or the same place value. All right? Now I have a little tricky question here. So watch carefully. Who wants to be my guinea pig on this one? Okay, you want to try this one? Now this is a what shape? A rectangle. How far from here to here? Okay, but it's just one something, right? It actually is an inch. That's very good. Okay, so it's 1. How far, if this is 1, how far up would it be here? Well, I'll tell you since you can't probably see them, but there's little delineations here, you know, and so this is 1 by 10, all right? And I know it's 10 because I can count 10 little spots here, okay? Now this one is what? This is where it gets tricky, I warned you now. How far from here to here? 1. How far up? This is the hardest part right here. 1 something, right? Because it's continuous, there's no little delineation, so but you're saying to yourself, but it's blue and it's the same length as the other one, so you want to think it's a 10, right? And later in algebra, I'll tell you why I like that. But for right now, this is 1 by I'm not sure, because I can't count anything. And my definition of algebra is when you can't know for sure what number it is, pick a letter. So what letter do you think I'm going to pick? X. That's excellent. Another joke. Okay. But you could pick A or B or Q, or if you're trying to figure out how many people or something, you could use P, or if you're looking for a question or the missing number, you can use N. What letters would you not want to use to represent algebra? Because they could be confusing. Well, X is okay, unless you're in Rome, then it would be Roman numerals or something, but you probably wouldn't want to use an O because you wouldn't know if that was an O or a 0. And you might want to steer clear of a I or an L because that might think it's a 1, right? So usually you want to pick a letter that's not confusing with a number, but you also want to pick a letter, if you can, that represents what you're talking about. But for right now, we're going to call this 1 by X, okay? Now, this is blue. This is a positive X. We also have negative X's, okay? Because this is a positive X, this is a negative X. What do you get when you add these two together? That's right, because this is nothing, right? Positive X, negative X. Okay, so we're going to do this last equation we just did a minute ago, and we're going to use it with blocks. 3x plus 2 equals 2x plus 4, and we're just trying to reinforce. Let me get some more blocks over here. Okay, so we want to show 3x. We have 1, 2, 3 x's plus 2. And then we want to show 2 x's. So we have 2x plus, whoa, that's a 10. 2 x's plus 4. Okay? Now, can I take the same amount from both sides now? Because what I want is when I'm all done to have x by itself and a number by itself. Okay? So could I take an x from both sides? Is that okay? Could I do that again? Yeah, I can take an x from here and an x from here. So now what I did was, though, I subtracted 2 x's from both sides, right? So now all I have over here is 4, and over here I now have x plus 2. That look right? Okay. Now, can I take a number from this side to make it x by itself? What number would that be? 2. If I take 2 from this, I have nothing. If I take 2 from 4, what do I have? I'm going to have a 2. So what I just did was I subtracted 2 from both sides, and now I have 2 over here, and I have x over here, x equals 2. Does that help? Okay. Now, when it's smooth, what that means is you don't know exactly for sure. Now, this is not a perfect analogy because it should stretch, because it turned out x was only too high, right? But this means it's an unknown. But it could be a variable as well. All right. Now, if you have an unknown, though, this is pretty simple with the adding and the subtracting. What if you had dividing? What if you had something like this? Can I multiply both sides by 2? How about by 5? Is that okay? So 2 times 5 equals 2 times 5. Is that okay? Okay. And so now I have 10 equals 10, no problem. So what if I have this? 1 apple, because you have to use apples when you study math, right? You always use that for your examples. 1 apple is the same as 4 ounces. Is that okay? Could I multiply both sides now by 5? As long as I multiply both sides by the same amount, I'm okay, right? So 5 apples then would weigh how much? 20 ounces. Okay? So that's okay. Okay, so how about if I went backwards now? What if I was to start with 5 apples equals 20 ounces, but I want to know how much 1 apple weighs? What do? Divide both sides by the same number, divide them both by 5, and now I have 1 apple weighs 4 ounces. Is that okay? This is pretty simple stuff, isn't it? Don't hold on, though, because here comes the tricky stuff. Who knows what an LCM is? LCM. Least common multiple. Describe that to me. What's a multiple? What's a multiple of 5? 1. Okay, a multiple of 5 would be what?
15.
15. Give me another multiple of 5. 25. Another one. 50. So 5, 15, 30, 50, these are all multiples of 5. In fact, who knows how to skip count? Skip counting would be 5, 10, 15, 20, 25, 30. That's where you're given your multiples of 5. Now you were thinking of factors. Factors are little, I think of it like factors or fractions. They're smaller parts, but multiples are from multiplying. So 5 times 3 is 15. 15 is a multiple of 5. All right? What's common mean? Yeah, we don't use the word common very much in the real world either, but okay, it means 2 things that they share, that they have in common. All right? What's least mean? Lowest common multiple. Now, you don't always have to have the lowest common multiple. To me, the common multiple is the key, but let me show you where this applies. Let's say we have an equation like this. 2/3 x plus 5/6 equals 3/7. Does that look like a fun problem? Who thinks it is? No, I don't think so either. Because what you'd have to do is you'd have to subtract 5/6 from 3/7, right? Then you'd have to multiply by the multiplicative inverse, the reciprocal. Oh, it's a bunch of work. So let me show you something that we can do to make this an easier problem. The key is the denominator. We want to be able to multiply this entire equation, both sides by the same number, to get rid of all the fractions. So what number could I multiply times both sides of the equation to get rid of all the fractions? What?
42.
That was an excellent guess. How did you get that?
By multiplying 6 and 7.
Okay, she said, for those of you who weren't listening, 42. But here's how you find 42. What you do is you take the 3, and you take the 6, and you take the 7, and you find the factors. So what are the factors of 3? Well, 1 times 3, so really just 3. So he's all okay. 6 would be what? 2 times 3. How about 7? And he's a prime number 2, so we're just going to leave him 7. So what you need is you need something that has a 3 in it, something that has a 2 in it, because this would be the 3 for this guy, and this would be the 6, which takes care of this guy, right? Then you need a 7 in it to take care of him. Okay, so what's 3 times 2? 6 times 7? 42. Let's try it. Let's multiply 42 times this side, 42 times, in other words, we're multiplying 42 times everything. Okay? So, if we multiply 42 times this, and that becomes 14, 14 times 2 is 28x. Now, people make this mistake. They think, oh, now this is 14. No, I'm having to take a whole new 42 times the 5/6. So we'll just put a little 42 over here, a little ghosty one. 42 divided by 6 is what? 7. So I can divide those both by 6 and have 7 times 5 is 35. Good. Okay, what's 42 divided by 7? 6. 6 times 3 is 18. Now, which problem would you rather do? This one, okay? So this is a practical application of, you may be wondering, why am I learning how to find the least common multiple? Now, if you wanted to, you could have used 84. 84 would work. Just multiply them all together. You could take 3 times 6 is 18. 18 times 7 is what? 126, I think. You could use that if you want. There's a couple different multiples that are in common, but as long as you get rid of the fractions, you're in good shape. Okay, now that we have this, we can subtract both sides, 35. So we get 28x equals negative 17. Divide both sides by the same thing, and we have x equals negative 17/28, right? Do you want to check that? Neither do I. But if you put negative 17/28 up into here, that should make an equation, make both sides the same, okay? You get that? Now sometimes, though, you don't have fractions, you have something called a decimal fraction. And a decimal fraction, let's try this one, 0.05x plus 0.35 equals 2.7. Now, why did I call that a decimal fraction? You ever heard that expression before? Usually you look at that and you say it's decimals, right? But decimals are just different ways of writing fractions, because I could write this as 5/100ths. This could be 35/100ths. This could be 2 7/10, right? So decimal fractions, they have a little they have that in common. Now, think about the fractions, what we just did with least common multiple. What number could I multiply by hundredths, by tenths, to get rid of all the fractions? What do you think? If it was just this up here, what number could I multiply by those fractions to have no fractions? 100, right. Now, think of that again. Let's go back down here. If we multiplied this by 100, this decimal point would move 2 places to the right, wouldn't it? So then we'd only have 5x. And if we multiplied this by 100, we'd have 35. And if we multiplied this by 100, what would we get? We'd have 27 and one more, because you're going to move it 2 places to multiply by 100, which makes it 2 more places. So that would be 270. Very good. Again, which problem would you rather do, this one or this one? If you really have nothing else to do but do hard problems, go ahead and just do this one. But I like to make things easier if I can. So now I can subtract 35 from both sides. I've got 5x equals 235. Now what? Divide by 5? You know, dividing by 5 and multiplying by a fifth are the same thing, aren't they? Because that line means divided by. So whether you take a fifth of both sides or you divide both sides by 5, you get the same thing. So x equals, what's 5 into that? Okay, let's do it real slow. That's a hard problem again. What would 5 go into 200? 5 times what would give me 200? 40. And then 5 into 35? 7. Good. 47. People that I know that are, people would say, oh, they're really good in math. It's not that they're really any smarter, but they just know how to make tough problems easier. Okay? So that's one of the things that I would just encourage you to do. Don't try to do this in your head. See, think, how can I make that into 2 things that I could do in my head? So 5 into 240, 5 into 35, 7. Okay? All right. Okay, we're going to take one more shot at me winning hangman. Okay? Now, we're going to start over here. So you're going to be quick now for the audience. So which letter do you want? B. Okay. Very good.
A.
A. That's, what do we do for a head? A little green. Okay, no A.
G.
G. Oh, G. There isn't another one of those either. Ooh, I'm on a good start.
S.
E.
O.
O. O. Leg. I. Okay.
T.
T. Oh boy, you're getting close again. V. I mean, yeah, good job. Yes. Yeah.
D.
R. Everybody? U. Man, I'm going to find one of these words you guys don't know. Okay, what does distributive mean? What word do you see in that one? Distribute. What's it mean to distribute? Like, what if I was to distribute money amongst all of the room? I would give you each money, right? I would distribute, pass it all along. Okay, so here, let's try this distributive. And it's similar to commutative and associative, but I'm going to show it first with the blocks. What are those two blocks? Okay, what food does that remind you of? That's right, so that's chocolate 8. If you're not familiar with the blocks, that's chocolate 8. So that's 2 8s. So this is, by the way that we show multiplication is we build rectangles. And rectangles have, this is from here to here is 2, and from here to here all the way up is how much? 8. And what is 2 times 8? 16. Okay? Now, is that the same as, this is your 5s, 2 times 5 plus, I used the legs from Mr. Hangman, 2 3s. So 2 times 3 and 2 times 5. Right? What's 2 times 5?
10.
And what's 2 times 3?
6.
Okay, so the way we would write this, though, was we would say 2 times 8 is the same as 2 times 5 plus 2 times 3. And what is happening is 2 is distributed. And you could even write that as 2 times 5 plus 3, right? So then you take the 2 times the 5 and the 2 times the 3, and you distribute the 2 all the way across. Does that make sense? Okay. So what if we had something that didn't use the block so that we could see it so clearly, and we had something like 8 times d plus 3? How would we distribute the 8 across? Now, I don't want to confuse you, but here's what I usually do. I usually put little things like this to mean that that's 8 times the d and then 8 times the 3. Okay? So what that would look like is 8 times d plus 8 times 3. Is that okay? Okay. And what is 8 times 3? You can multiply it out. Okay? So, as I said before, oftentimes, well, what's 4 times 12? Real fast. Who's not real sure real fast? Come on, admit it. You're not real sure right away. Am I the only one? Okay. So how would we use the distributive property to help us here? Let's just take it apart. What's 4 times 10 plus 2? Isn't 10 plus 2 the same as 12? And so isn't that the same as 4 times 10 plus 4 times 2? Is that okay? What's 4 times 10? 4 times 2. So 48, right? Or 48, not 48. All right. This okay? You see how the 4 is distributed by both of them, okay? Let's just see how clever you are now, though. 3 times something plus something is 3a plus 3b. What goes in the parentheses? You sure? Yeah, because you can go backwards. See, now I'm giving you what has been distributed, and you can see, well, there's the A and the B, and let's check it. 3 times A, 3 times B. Is that okay? Okay, let's try one more. How about that? How would I write that? Going backwards. See, now I'm giving you what I gave you here. So what number is distributed by both of these? What number is common to both of these?
7.
Okay, so I think the 7 goes out front. I think you're right. Okay, what 2 numbers would go inside?
X and M.
Well, not numbers, letters. Right. X and M. Is that okay? Good. Doing well. Okay, so this is the distributive property, and we can either give you this and you distribute it to find this, or we can give you this and you can go backwards to find out what has been distributed and what were the original factors. Good. What would you call that? A number line. Why would you call it a number line? It's a line with numbers on it, okay? Now, what do these arrows mean on both sides? Okay, that it goes on and on how far? The largest number that there is you can think of, right? Which we usually say infinity. We draw a little sideways 8. But this goes all the way. That's what these arrows mean. And this goes all the way negative, and 0 is in the middle of our number line. Now, we call these numbers. You could also call them integers. Integers are the counting numbers, and 0 is also included in that. Where would you find a word like, if you were going through the Algebra 1 book and you said, it's an integer, where would you find that information? In the back of the book. We have this thing called a glossary. So anytime you run across a word that you don't know what it means, you look in the back of the book and you can find out what it is. All right? Now, there's more to this number line than you realize. This number line also represents not just the numbers, it represents everything in between the numbers. So where would I show 1/2 on this number line? So like 1/2 would be like about right here, right? Now you haven't had geometry yet probably, because you usually take Algebra 1 before geometry, but this is a line, and a line is made up of an infinite number of little points. So don't just think of a number line as having 1 and a 2 and a 3. It's got everything in between. There could be 1/16, 1/8, 1/4, 7/8, 15/16. Everything's on this number line. Okay? This is an infinite number of little values. So where would you find the square root of 3? Well, the square root of 3 is about 1.4 or 1.7, I think. So that would be like around here. There's the square root of 3. Where would you find pi? What's pi equal to? It's about 3.14, like that. Okay, so that would be a little bit over 3, so about right here. So that's where pi would be. You get that? So where would negative 4.2 be? It'd be negative 4 and a little bit past it, okay? So whenever you're looking at a number line, don't just think, oh, I can see 1, 2, 3, 4, 5. That's just there to give you guides, but really it represents a whole bunch of values, okay? Now, sometimes I'll ask, oh, what am I doing? Better put those back on there. What if I ask the question, show me all the even numbers between, let's make our number line a little bit longer here, between 1 and 7. All the even numbers between 1 and 7. What would you do? How would you show that on a number line? The even numbers, the whole numbers, even numbers between 1 and 7. What are they? What's the answer? 2, 4, and 6. So what you would do is you would just color in the little dots, 2, 4, and 6. And that's how you would do that. What if I said, show me all the numbers between negative 3 and 1? How'd you do that one? All the values, I mean, between negative 3 and 1. Everything between negative 3 and 1. How'd you do that? Well, here's negative 3, and here's 1. And what you'd do is you would color in the line. You would put like a thick line because, don't forget, between 1 and negative 3, there's also 1/2 is in here, negative 1/2, right? It's all the values in there. Okay, here's a trickier one. Show me this one. All the values that are greater than negative 2. How'd you do that? Okay, a dot on negative 2 and then a line going which direction?
Right.
To the right. Are you sure it should be a dot? Or should it be a hole? See, what you want to do is this one, you'd want to put like a circle, which means it doesn't include negative 2, but it would be everything that's greater than negative 2. So you'd have a little colored line going in this direction like that. Okay? If I put this greater than and equal to negative 2, then you would color it in and put the thing here, okay, with the arrow. Does that make sense? Y'all get that? Boy, I wish you all had number lines in front of you. Then we could give you another problem. Show me this one. X, all the values greater than and equal to this. Go ahead, show me that one if you got paper. And if you got this at home, you could pause the machine, and then you could turn it back on again to see the answer. Okay? So where would 5/2 be on the number line? What is that really in terms of a mixed number? That would be 2.5. So we'd go to 2.5, and that's about right here. Now, do we put a solid circle or do we put a hollow circle? If it was just greater than, I'd put a hollow. But because it's greater than and equal, I'm going to put a solid. It would be like that. Okay? Get this okay? All right. I'm going to give you one more. A, with our messy number line, less than square root of 2. Who thinks they could do that one? What's the square root of 2, approximately? Just approximately. It's a little over 1. I'll just tell you, it's about 1.4. Now, how would I do less than? First, I find 1.4. That'd be about right here, right? So there's 1.4. And now which way am I going to go? This way or this way? Less than, go this way. So I would put a hole here because it's not equal. So it would be a hole, and then it would be this like that. Get that okay? Okay. Now, what if I was to take two number lines and put one of them like this, and then I could have another one going like this. One of them vertical, one of them horizontal. You ever seen anything like that before? What do you think I'm leading towards? Yeah, but think of a number line going this way and a number line going this way, and you superimpose one on top of the other, and most of the time this is our X and this is our Y. But remember, these are just number lines. Okay? Now I have two number lines. Has anybody here ever played Battleship? Okay, do you have a grid and you have like A through what? Is it like J, something like that? Then you have 1 through 10, and you put your little battleships on. You say, okay, A4, and then you go over A and up 4, right? Who's played that? Let me see your hands again. Okay. See, when I used to teach this in school, I used to have fun with this because I got a big board and I put a big graph and I put it in the middle of the classroom and I put battleships. Well, the one team, half the class, got to pick out where to put the battleships. Then the other half of the class had to guess, and whoever won the game got an A for homework that day. So I had a lot of incentive, plus it was fun and they weren't doing schoolwork, right? Okay, so if you think of this as a battleship board, except instead of going from A, B, C, D, E, F, G, H, I, J this way and 1 to 10 this way, or however it goes, we're going to go, these are the positive numbers. This is 1, 2, 3, 4, 5, 6. And this is positive. This is 1, 2, 3, 4, 5, 6. Okay? What would this be down here? Negative. So that's negative 1, negative 2. What's this over here? Negative 1, negative 2. Okay, now, this represents a big flat area called a plane, like this whole board here. A number line by itself is just how long something is. But a plane, okay, so let's say that I was sitting right here. Okay, well, pretend I don't see anything. Maybe a big fly just landed on the board right there. And I'm not going to look at it. And I want you to tell me where that fly is. Okay, so tell me what I have to do. I'm not getting it. Keep going. How would I find it? Go ahead. Okay, so I get one shot with my fly swatter and I'm blind, see? So I need to go over 4 this way. Oh, up 4 here, and then I can go hit it, right? You get the idea? Okay, because in a plane, every little point is going to have an over part and an up part. It's going to have 2 coordinates. It's going to use 2 number lines. Because if you just said over 4, it could be here, it could be here, it could be here, it could be here. So I had to know whether to go up or down, right? Okay. Now, who was the first guy to develop this? Do you know that? It's a little scary to me because the first guy to develop this did it when he was a teenager. His name was René Descartes. And when you think of it, how do you spell Descartes? Does anybody know how to spell Descartes? How? Like D-A-Y-K-A-R-T? Does that sound right? Descartes? No, because it's not English. And so what it is it's Des Cartes. And you say Descartes, all right? So that's how you pronounce it to yourself. Do you ever do that when you try to spell a word? You say, like, how do you spell Connecticut? What do you say to yourself? Connecticut, right? Helps you to understand it. So Descartes, and if you take away the D-E-S and you put I-A-N over here, what do you have? Cartesian coordinate system. So every point has 2 coordinates. It's got an over coordinate, either this way or this way, positive or negative, and it's got an up or down, positive or negative coordinate, all right? Every single thing. Do you ever do Etch-a-Sketch? You have 2 little controls, right? Which way they go? One of them goes up or down, and one of them goes side to side, right? And you have to be really good to find out how you're doing. Okay. So what I'm going to do is I'm going to bring up our ready-made coordinate board here. So what do we call these numbers here? Which coordinates was this? This is the x, and what about this one going up and down?
Y.
This is the y. These are positive, negative, positive, negative. And it turns out you have 4 quarters, but instead of quarters, we call them quadrants. And this is quadrant number 1. We'll use Roman numeral 1, 2, 3, and this is the 4th quadrant down here. Okay? Now, I have 4 different coordinates or points. Now, don't forget, how many points are in this whole board here? How many? Well, there's 1, 2, 3, 4, 5, 6. So there's 6 by 6. There's 36 in each thing. So you think that would be how many points there are? How many points are there? Go ahead. Somebody tell me this. I'm dying to know. Infinite number of points, because there's also a point here and a point here and a point here. So these graphs are just to get us close, like the number line, but there's actually an infinite number of points. And what do these arrows mean? And this keeps going forever and ever and ever. It's a huge plane that goes out into outer space, okay? There's millions and millions of different points. Okay, so how would it show me 3, 2? How would I get to 3, 2? Someone tell me. What would I do? Over which way? To the positive or negative? Positive 3.
And then
Up 2. Okay, so we'll put it right there. And we're going to call that point A. And the coordinates are 3, 2. Now, I don't have to put positive 3, positive 2. If they don't have a symbol, then we know that they're positive. Okay? Okay, how about this one? You do this one. Negative 3, 4. Okay, so that's, I'm always going to do the horizontal one first. Okay, so -3 and up 4. Okay, so that'd be right there. And that's point B. Okay, here's yours in the back. -2, -1.
Back 2.
Okay, this way, -2.
And then down 1.
Down 1. Very good. That'll be our point C. And this is yours. Ready? 2, -4. So if I want to go +2, which way do I go? This way or this way?
Right.
Yep, that's right. So +2. Now -4. Up or down?
Go down 4.
Very good. 1, 2, 3, 4. And so this is our point D. Okay? Those are the coordinates. So if I ask you to find me, which one is 3, 2? Everybody? What letter? 3, 2 is A. How about -2, -1? C. How about -3, +4? How about 3, 2? Ah, gotcha. You thought I was going to do D. It's 3, 2. Okay, so this one is 2, -4. Okay, all set with this? Because now we're going to start graphing. We're going to start drawing things on this Cartesian coordinate system. So get comfortable with finding the points and which is positive, negative, etc. Okay? Okay, before we get too much into drawing and making equations, let's just refresh our memories for just a second. Why do we learn math? To do real-life applications. The reason that you're learning math is to help you solve problems in the real world. Okay? I'm trying to shy away from the expression word problems because then everybody that gets a little nervous. But a word problem is a real-life situation. Okay? So I'm going to start this next unit before we get into all the technical details. Who likes to bake here? Any bakers? All right, let's say we're going to pick on Heidi. Okay, Heidi likes to bake. Okay, now let's say that you are going to have a big bakerama coming up, or your church bake sale or something, and you're going to try to raise money for something. And so the night before, you get out all your ingredients, and you make sure the oven's working properly, and you get all your bake pans out, and then you're going to make 2 loaves of bread. You have a special kind of a whole wheat with all kinds of additive things, secret ingredients, all right? So you're going to make 2 loaves of bread just to make sure everything's working properly. So the night before, you get 2 loaves, and your mom is going to be like wanting pictures of this for your album or your portfolio or something, okay? So she comes in with her camera, takes one picture, and there you are standing there with 2 loaves of bread, okay? So in the morning, you get up, and you are set. This is all you're going to do for about 10 hours. You're going to make bread. And she finds out that once she gets going, she can make 3 loaves of bread for every hour, all right? So when you first started in the morning, at 0 hours, you had how many loaves of bread from the night before? 2. So the first picture that would be just Heidi with 2, right? Okay, now what happens is you start rolling. And so after 1 hour, how much bread do you have? 5, because she had the 2 that she started with, plus the 3 that she just made the first hour. So now she has 5 loaves of bread. How many loaves of bread will she have in 2 hours? How'd you get 8? That's right. How'd you get it?
Because you take from the first hour and then add 3 more.
Add 3 more. For every hour, you add 3 more, right? So she's making 3 per hour, but she started with 2. So at 2 hours, she has 8. How many would she have in 3 hours? 11, right? Because she has, keep adding 3 per hour. So 3 hours, she got 11. How many would she have in 10 hours, Evelyn? So 10 times 3 per hour is how much? 30. Plus how many did she start with? 2. So how much is that? 32. Very good. Okay, you get the idea? Okay, can we make an equation out of this? Now let's see if we can write this out. So we can put the amount of bread was how many per hour? 3 per hour plus 2 that she started with. You see that okay? So every hour she gets how many loaves of bread? 3. How many did she start with? 2. Okay. Now let's see if we could draw that on our graph, but instead of making this y, we're going to make it bread. Instead of x, we're going to make it hours because we're in charge, right? We can do anything we want. Now, let's draw these points because this is our h point. Remember, this is the x, this is this way, and this is our y point. This is up or down, right? So at 0 hours, where would 0 hours be on this graph? Yeah. Right in the center, because this is the origin. That's 0, 0. It's not any far this way, it's not any far this way, it's just 0, right? Okay. So, but at 0 hours, right here, she made 2 loaves of bread. And that would be here, so that would be this point right there. Okay? How do we draw this point? 1, 5. Well, now instead of going 0, we're going to go over 1 and up 1, 2, 3, 4, 5, and that would be right there. Where would this point be? 2, 8. Well, let's get close. I know we're off the graph because it only goes to 6, but let's go 1, 2, and 1, 2, 3, 4, 5, 6, 7. That'd be about right there. And where would 3, 11 be? Way up there, right? You see how there's a little relationship, though, because every time you go over 1 more hour, you go up 3 loaves of bread. 1 more hour, up 3 loaves of bread. You see that? So if we went over 10 hours, we'd have 32. And if we connected these dots, what would we have? We'd have a straight line, right? Okay, but before you start thinking about lines and graphs, let's remember this represents real things. Okay? Let's try another one. Let's say that Roger owes his dad $3. Okay? So he's, what I would say, he's in the hole. $3, right? Just to get started. How would I show owes $3, in the hole $3? How would you show that with the graph? It'd be -3. But before we go there, let's just do this. Let's put dollars and let's do block sets. Because Roger's going to come to work for us and he's going to put together all the blocks into a, from all the big boxes into a set. And you're going to get $1 a set. Okay? So when you first started, though, you have how many dollars? Before you get warmed up here, how much money do you have? Okay. Let me change this over here. This is blocks and dollars. So before you get even started, before you've done any block sets, you have -$3, right? Okay. After you make one block set, how much and you pay your dad, now what are you? You're -2, right? Boy, you're getting faster. Now you make another block set. Now what are you? You've done 2 block sets, but now you're only -1. You make another block set, and where are you? 0. You make another block set, where are you? Now you got $1 to the good. You make another block set. Okay, you get that? So $1 for every block set, right? So on our graph, this would be blocks, and this would be dollars. And we started at 0 blocks, he was -3. And then for 1 more block, he's now -2. Every block set, he gets another $1. Every block set, another $1. Every block set. Get that? And we could connect all those dots and make a what? A straight line. Okay. But I hope I could just kind of infuse this into you that the reason that you're learning how to draw lines is to represent real things. Whether it's, now one time I was teaching a lobsterman how to graph lines. I was. And you know what I was teaching him? I said, okay, you're a lobsterman. Okay, every time you open a trap, you find 3 lobsters. Now I'm assuming that it's the same amount of lobsters all going into little traps, okay? and maybe he had 4 in his container when he started. So he would be here when he first started, and every time he opens a trap, 3 more lobsters. 1 more trap, 3 more lobsters. Okay? And I would write that as lobsters equals 3 per trap plus the 4 I started with. Another time I was tutoring a young lady who worked at Burger King. I just got to know her a little bit, and so I said, okay, what do you do at Burger? She was a hamburger flipper. So I said, okay, every minute you make 3 more burgers. So how many burgers did she make in 5 minutes? Well, every minute, 3 burgers. Every minute, 3 burgers. I don't know. I'm not saying that Burger King makes their hamburgers in a minute. I'm just telling you that these dots represent what? They represent real things, okay? So do the problems in the book until you get comfortable with this, because then we're going to have a lot of fun with graphing lines. Okay, does anybody here ski? Okay, what do you call it when you go down the slope? Okay, so when we graph lines, lines have a slope. And again, let's say that you were trying to describe a line to me. How would you describe a line? Would it have a steep slope or kind of a, what would you call this? What's another word besides non-steep? Flat, flatter slope, okay? But when we graph lines on our coordinate system here, who's this coordinate system named after? Descartes, Cartesian. Good. Okay, so let's just pretend again that we're going to start in the origin, and we can make, for every one day we made 3 loaves of bread, and then the next day we made 3 more loaves of bread, and we drew a line connecting these points. That's a pretty sorry line. Let's try that again. Okay, so we have a line, and we could put an arrow there to show that it keeps going. Now, how would you describe that line? Would you say that's a steep slope? Okay, what we're going to do is we're going to measure the slope by making a triangle. Now, we could either make a triangle from here over here. We want to make a right triangle with a right line, a right angle at the corner. Or we could go all the way over to here and make this triangle. Let's do both of them. The little triangle, how far is our over part? 1. How far is our up part? 3. So we would say that our slope is 3 over 1. And by the way, where do you ski? In valleys or on mountains? Okay, so what we're going to do is we're going to call M, that's how we're going to be our slope. So think of mountain slope when you see M, okay? And we're going to say that our slope is the vertical over the horizontal. Some people say it's the rise over the run, but it's a fraction, and it's the up part over the bottom part. So we would say our slope is 3 over 1, right? Or we could just say our slope is, what is 3 divided by 1? A whole number 3. But if you see M equals 3, remember that could be 3 over 1. That means it's over 1 and up 3. Over 1 and up 3. What if we did the big triangle? How far from here to here? 2. How far all the way up? 6. So is that the same as 3 over 1? Yeah, it's the same slope, right? Okay. So let me draw a couple of these, and you see if you can figure out what our slope is. Let's try this one. Okay, what's the slope of that one? Is it steeper? Would you want to go down this one? If you did, go very carefully, right? Okay, is it snow plow you do? Make yourself go slow? Okay. How far over? How far up? So our slope is our rise. What's the rise in this one? In our little triangle, we've got 2 components. You've got this part and this part. So it's 5. And what's the run? 1. Do you like those words, rise and run? Because you could do, well, this could be the y part, right? Because it's how far up. It could be the vertical part. It could be the over and the up. Do whatever you want. But oftentimes in old textbooks, you'll see the rise and the run to find your slope. Okay? So how about this one? A little trickier now. What's my slope if this line right here? That's supposed to be to there. Boy, I'm not doing well with my drawing lines today. Should get a ruler up here. Okay, what do you think the slope is there? Is it as steep as the first one? Okay. What did you notice? Is there a relationship? Like the higher the number, the steeper it gets, right? Okay, and the lower the number. So what about this one? How far over, if we made a triangle to find our slope, how far from here to here? How far from here to here? Okay, so what's our slope? It's the up part. We'll do this one with arrows. Over the over part, it's 3 over 3, which reduces to 1. Okay, our slope is 1. Well, how about this one? See what I got in the book here. Use the same ones. That's more like my kind of slope when I go skiing. I think I only did skateboarding one time, and the thing went right out from under me. I went, whoom! And so I learned my lesson. Okay? I'm not much of a skier either. So what do you think the slope of this would be? How far over are we going? 4. How far up? Okay, so if that's 4 and that's 1, we made a little triangle. So we want to measure our slope. So the up part is 1, the over part is 4. So what's our slope? 1/4. We just leave it 1/4, right? Okay. That's okay? Now, all these slopes have been a positive 4 and a positive 1 because we're going positive direction there, positive direction there. And so these are all positive slopes. We haven't written any positive signs because if it doesn't have a sign, it's positive, right? So maybe you could think of it when, as long as you're leaning forward as you're going down the slope, is that a positive skiing experience? Yes or no? Yes. What if you're leaning this way and your feet are about to go out from under you? Is that a positive or negative experience? Negative. A very negative experience, okay? Because it's possible to have positive slopes and negative slopes. So let's see if we can draw some other slopes representing negative ones, okay? First of all, where would you ever have a negative numbers in real life? What did I use when I described being negative numbers before? Yes? Money. That's about what most people think about. You're owing money. You're in the hole. There are businesses, when they start, that lose money every day. What thoughts are going through your mind right now? Change your business. No. Sometimes you have to lose money at first until you begin to catch on, and then you begin to make money. So let's say that you had a business that was, for every one day, every one day, you lost $2. Okay, so let's say you go over one day and you lose $2. And then the next day, you lose $2. And the next day, you lose $2. What's that line going to look like? See that? Okay. And I could continue it if I wanted to. I could keep this going right up here. Okay. So how are we going to measure the slope here? First of all, is it a positive slope or a negative slope? Okay. It's nice for me when I look at a line right away, because I've done this for so many years and so many times, I can tell if it's positive or negative pretty fast. But you should be able to get that eventually. Just look at it and estimate it. So that's a little clue to help you with that. But let's just, if you ever forget, what do you draw to measure slope? Triangle, a right triangle. So where do you want to make the triangle from? You can do anything you want. You could go from here all the way down to here. You could go from here to here. You could go the little one from here to here. Okay? Or you could do the first one we did. Okay, so for this one right here, we went a positive 1 over, right? How far from here to here, though? Negative 2. So our slope would be negative 2 over 1 is negative 2. So our slope, mountain slope, negative 2. We could have gone all the way over to here. This is a positive 3 and a negative 6, and we would have still had negative 6 over 3, negative 2. Get that okay? There's all kinds of ways you can find slope. There's lots of ways you can make triangles to figure them out. All right? Measure this slope. See if you can do this on your own. And if you're home watching this, you can pause after I draw it and then figure it to get the solution. What do you think the slope is, first of all, positive or negative? Negative, because it's leaning backwards, right? Let's measure it to be exact. How far from here to here? -3. How far from here to here? +3, right? So we put the rise or the up part on the top, and we put the other part here. And what's 3 divided by -3? -1. Good. Getting this okay? I thought of another one where it would be negative. What if you were, for every one day, the temperature dropped 2 degrees, and the next day it dropped 2 more degrees? So degrees dropping would be negative, right? Below 0. Okay. One more. Okay. What do you think the slope is first? Positive or negative? Negative, leaning back. Is it a steep slope? It's not bad. If you were on a car, that'd be moving pretty fast, right? But let's measure it to be exact. How do you want me to do it? Where do you want me to make my triangle? All the way or halfway? Who says all the way? Okay, who says halfway? Okay, we're going to go all the way. So from here to here. How far from here to here? 4, right? How far from here to here? -6. So our slope would be the up part, the vertical part, over the horizontal part. 4 over -6. What's that reduced to? And if the negative sign's here, could I put it up here? Could I put it outside? Doesn't make any difference. As long as I got that negative side somewhere, it means it's a negative slope. And by the way, look, it could have been right here, which would be 2 over -3, which is what we found out, right? Okay. You feel pretty comfortable with this? Okay, you're measuring slopes. Now, let's do something a little trickier. This time, I'm going to, well, let me just show you this. How many lines are there that go through a certain point? Let's say if I have, okay, like this, and then we're going to have one that goes like this. What do you notice about all these lines as I'm drawing them? What kind of lines are they? Parallel. What's a parallel line? I mean, why do you know these are all parallel?
It looks exact. Each one looks exactly like the other one.
Okay, but keep going.
They're never going to touch.
They're never going to touch. What do they have the same of?
The same slope.
They have the same slope. Each one of these is, by the way, over 1, up 2, over 1, up 2, over 1, up 2, over 1, up 2. All of these lines have the same slope. What is the slope? 2 over 1 or 2, right? It's a positive 2. So if I was talking about these lines, and let's say we labeled them, what do I have here? I think I have C, N, and D, okay? How would you describe the difference between line C, line N, and line D? Yes?
Where it intersects on the Y.
Okay. You could do any one you want, but the way that we're going to do it is we're going to talk about this axis right here, the Y line, and where it cuts across this line. Now, we don't use the word cuts across. We're going to use the word intercepts it. Now, here's how I think about it. Once when I was a young lad, why are you smiling? It wasn't that long ago. Okay, I was a young lad, and we were out throwing rocks, and we spotted a wasp nest hanging from a tree. It's almost too much temptation for a young lad. So what do you think we did? We threw rocks at the wasp nest, and you do it because you're, you know that you might get burned here. But anyway, so I nailed it. I mean, I can remember that rock just hitting right in the side of that kind of papery nest, and those wasps came boiling out of there like crazy. What do you think we did? We began to run furiously away from the nest. And one of those guys hit me right in the back of the thigh. It was like someone shot me. And So I think of that, instead of calling them wasps, let's call them bees, okay? Because that bee hit me right in the back leg. He intercepted me as I was running away. So the reason I use this analogy is because, what does this mean? Slope. This is our mountain slope. Whenever you see M, it means slope. Okay, but the B is the intercept. Okay? So where does this intercept, this line right here? What's the slope? 2. Where does it intercept the y-axis? Right here. And what is y at that point? 1, 2, 3. Okay, where does this one intercept the y-axis? 0. Where does this one intercept the y-axis? -4. So how many different lines are there that have slope +2? Infinite. I could have a whole raft of lines that have that slope. The only way I can tell them apart is by their intercept, okay? So the intercept here is 3, intercept is 0, intercept is 4. So what we could do is we could draw these lines as y equals 2x plus 3. Okay? Now let's go back just a second, because I'm going to lose you here if I don't do this. Do you remember when we first started our talking about lines, we talked about making bread, right? And you remember you had 2 loaves of bread to start with and you made 3 per hour? Let's just switch it a little bit. Let's say that you started with 3 loaves of bread, and for every 1 hour you made 2 more loaves of bread. Next hour, 2 more loaves of bread, okay? So your slope is 2, and how much you started with is b, okay? So who can tell me what the equation of this line would be using the slope-intercept formula? What's my intercept? 0. What's my slope? 2. So I would put y equals 2x plus 0. What's 2x plus 0? We don't have to put that if we don't want to. You can if you want, okay? What would this one be, do you think? What's my slope? 2x. What's my intercept? -4. That means you owed your next door neighbor 4 loaves of bread before you started making them, right? So you started in the hole 4, and every 1 hour, 2. Every 1 hour, 2. After 2 hours, you were back to even. Then you started making them 1 hour, 2 more loaves of bread. See that? That makes sense? Okay, let's do another one. Have you ever seen that form before? Who's never seen this slope-intercept form? Who's seen that before? Let me see your hands. Who's never seen it before? Okay, this is new stuff. This is good. But whenever you see an m or a b, y equals mx plus b, this tells you your slope. This is the little triangle. This tells you how far over, how far up, right? And usually the m, if you think of it like m over 1, the m has 2 components, how far over, how far up. What's the b tell you? Where it intercepts the y-axis, right? Okay. Let's do some more lines here. We're going to go through here. Okay. They're supposed to be parallel. They're close. Okay. So what do you think my slope is first? Is it positive or negative? Negative. How'd you know that? It's falling backwards, right? Negative experience going down the slope. Okay, so it's probably going to be negative, but let's measure it to be sure. Let's just pick a point here. We'll pick a point here. We can either, by the way, you can go 2 ways. I could go up here and over here if I wanted. Doesn't make any difference. How far from here to here? Positive or negative? Positive. How far from here to here? -3, good. So my slope would be the up part over the horizontal part, or the rise over the run, and be -1. Everybody agree with that? So for every 1, I should be going up 1 over 1, up 1 over 1, right? Okay. Describe this line to me here, the top line. What's my slope? -1. So m is -1, so I've got y equals -1 times x. What's my intercept? Cody, right there. Where does this line intercept the y-axis?
+2.
Very good. So I just put a 2. Okay? The next one is yours. What's the slope of this one?
1, -1.
-1, good. So I put y equals negative. Do I have to put the 1 in there? Because -1x is the same as -x, right? So whenever you see -x, remember there's a 1, kind of a ghost in there. He's hiding, but he's there. Okay, what's my intercept here?
0.
0. How am I going to write that?
You're not going to,
I don't need to write it, right? Because I could put +0 or just leave it blank. Okay? So this one's yours. Yep. What's the slope? -1. Okay, where's it go? Where's it intercept the y-axis? So -x, -3. Okay? Are you getting this? So if you see this, are you thinking, oh, that means something that leans back and it goes through the thing at 2. Leans back, goes through the origin. Leans back, goes through -3. See that okay? So you've got a slope and an intercept. So every line that there is has two things. It has a slope and then where it goes through the y-axis. Okay? If you forget how to find the y-axis, just show me one thing. What if you make x 0 here? What if x is 0? What's y? Oh, you mean if x is 0, y is -3? The intercept everywhere along this point, x is 0. So if you forget how to find the intercept, just make x 0. What you got left is the answer. Okay, let's try one more. What if x is 0 here? Where does this line cross the y-axis? Y is 2. And there it is right there. Okay, so this is slope-intercept. And now I'm just going to draw some lines from scratch. And if you want to pause after each one, and those of you that are working here, see if you can write down the slope and the intercept of every line that I draw. All right, now if you're at home, you could pause it, look at it, and figure it out, and then but I'm going to keep talking. Okay, if I'm looking at this, and here were the 2 points that we started with. This point here, which was 0, 1, and this point, which was 3, 2. Okay, that's our points. We put our points in little parentheses like that. So, first thing I want to find out is, what's my slope? Positive or negative? Positive. What is my slope? How far up? Okay, we're only going to make a triangle, though, from here, right over here, up to here. So how far from here to here? 1. How far from here to here? So our slope would be 1/3. Okay, what's our intercept? Where does it intercept the y-axis? Right here, right? So we would write it y equals 1/3 x plus 1. How many got that? Good job. Okay, let's draw another one. The points are, maybe I'll just tell you the points before I draw them. 0, -1, and -5, 1. So if you want to pause that and do that. 0, -1, and -5, 1. We connect these points, and I want to find the, first of all, positive or negative? Negative. Okay, let's make our triangle to find the slope. How far up? 2. How far across? Ooh, very good, -5. But see, if you forgot that it was -5, but you knew it had to be a negative slope, that would help, right? So estimation is a good thing. Okay, the slope's negative 2/5. Where's the intercept? Negative 1. So b is negative 1. So we have y equals mx plus b. Y equals negative 2/5 x minus 1. Anybody have that? Okay, you're a whiz kid. Let's get you another one. The points are 3, 1, and 0, negative 4. So that would be 3, 1, and 0, negative 4. So the line would look like this. Okay, somebody want to estimate it for me first? Positive or negative? Positive. Falling forward, leaning forward, having a very positive day on the ski slopes. Okay, so m is going to be positive, and then we make our triangle. Okay, so what's our rise? 4, 5. What's our run? 3. So what's our slope? 5/3. Very good. Okay, where did it intercept the y-axis? Negative 4. So we have y equals 5/3 x minus 4. Who got close to that? Good. It'd be better if we had graph paper for you, wouldn't it? Maybe we'll have to get some during a break. Okay. So the only thing you have to remember is a line has what characteristics? It has a slope, which is either positive or negative. It has an intercept, because how many lines are there that have the slope of 3? Million. How many are there that go through the origin? 1. How many slopes are there that a line has slopes negative 2/5? Millions. How many go through this point right here? Just one line. So you want to find the slope, find it's positive or negative, make the triangle, find the exact slope, and then you want to find out where it intercepts the y-axis. What does that look like? When you see that now that you've been so educated, what are you thinking when you look at that? A what? What's the first thing that went through your mind? Are you having flashbacks? What did the last lesson? We started with a whole bunch of lines and points, and eventually we moved those lines and points until we could draw, write an equation to represent those points. Now, during the break, somebody asked me this question. Do we ever use values of x and y? And we do. And does this equation remind you of our bread baking expert back there? Okay, let's try it. If you have, instead of bread equals 3 per hour plus 2, which is the first thing we did a couple lessons ago, now we're going to say instead of the hours, that's our x, and instead of the bread, that's our y, okay? So at 0 hours, how much bread do we have? Okay, now let's look. Let's put it in this equation. Y equals 3 times 0 plus 2. What's 3 times 0? 0. So y equals 2. All right? Now let's try another one. At 1 hour, we'll put the 1 in for the x. 3 times 1 is what? Plus 2. So then y equals 5. So y has a value now. And the key is how much she works, right? The key is how many hours, how much bread you're going to have. So the amount of bread is dependent on how many hours she works. So sometimes in math books they'll refer to this as the dependent variable because it depends on how much bread, how many hours she works. This is the independent variable, right? So let's try another one. So at 2 hours, how much bread will she have? Well, now x, or hours, changes to 2. What's 3 times 2? Plus 2? So she's got 8. And then we graphed it by going like this. At this point, when x is 0, y is 2. When x is 1, y is 5. When x is 2, y is 8. Remember? And then, okay, remember all this? Our slope is 1 over 3 up. 1 over 3 up. Because the slope is really per hour, isn't it? It's for every 1, 3. Get that? Okay, now we are going to be given not points, not lines. We're going to go the inverse. Now I'm going to give you equations, and I want you to draw them. Let me see if I can tell you just a little history. I don't know if this will help you or not, but I used to teach high school math. I used to teach algebra, and I used to teach geometry. And when you think of geometry, you mostly think of angles and rectangles and shapes and circles and all that, right? Triangles. It's things that you can see. But when you think algebra, most people think of equations like this. And Descartes, what made Descartes so ahead of his time is he was able to take an equation that was usually just numbers on paper and draw it. So what you are doing right now is you're combining algebra and geometry. You see that? Lines on a plane and points are geometry. Letters and numbers are algebra. Okay, so if I give you this right here and say draw it, what are you going to do? Okay, in order to draw a line, you need to find the slope and you need to find the intercept. And most of the time before, we were finding the slope first and then the intercept. I'm going to go backwards. So I want to find the intercept. Where does this line here cross the y-axis? And now this next one, it took me about a year of teaching it before I really got it. So take your time to think about it. But everywhere along the y-axis, what is the value of x? Think about this. Everywhere along here, what is x? What's x here? What's x here? Because x is 0 all along there. So all you have to do to find the intercept is make x 0. And so now we can find y because what's 3 times 0? Plus 2? So when x equals 0, y equals 2, and we could draw that as a point 0, 2. Where is the point 0, 2? 0, 2. You all get that? So whenever, okay, here's one sentence. Now listen carefully. Open up the gray matter to your brain. If you want to find the intercept, make x 0 and solve for y. That's it. Okay? So if you make x 0, 0 times 3, y equals 2. So you got x is 0, y is 2. That's the point. This is the x, this is the y. Get that okay? Okay, so we know that our line goes through that point. Now, how many lines are there can go through this point? Does this line go through that point? How about that one? How about that one? Infinite number of lines. But how many lines that have slope? 3. Only 1. So let's go back to our equation again. We know it goes through the point 0, 2. Now, all we have to do is find the slope, and the slope is 3, which really means 3 over 1, doesn't it? That means a triangle that is 1 this way and 3 this way. So we just go over 1, up 3. Could we go this way? It's still over 1, up 3, right? Same slope. So this, hey, well, I'll use the blocks. There you go. See that okay? So now we gave you the equation in the slope-intercept form, and you were able to draw a graph of the line. Good job. Okay, I'll give you another one. And if you want to pause it, y equals negative 3x minus 4. Y equals negative 3x minus 4. So if you want to pause this at home, and practice on your graph paper, and then you can turn it back on. Okay, what do we want to find first? Intercept or the slope? Intercept. How do we find the intercept? Make x 0. So all we have to do is put a 0 in here. Okay, so now we have x is 0, and we're trying to find out what y is so that we have a point with an x and a y part. The x will be 0. Okay, what's negative 3 times 0? 0. So what's y? Negative 4. Okay, so that would be right here. Done. So that's our point. 0, negative 4. 0, negative 4. Good. All right, now we're going to go back and we're going to find our slope. What's our slope? What's m? Negative 3. Could I make that into a fraction? How? Very good, Evelyn. So negative 3 over 1. Okay, so that means we have a triangle. What kind of triangle is that going to, what's it going to look like? Is it going to be leaning this way or this way? It's going to be this way, right? Because it's 1, negative 3. That doesn't look like 1, negative 3, does it? It looks like negative 1, positive 3. Is that the same thing? Because if it was this way, it would be positive 1, negative 3, wouldn't it? It doesn't make any difference whether you're going to go this way or this way. It's still going to be the same slope. So it's going to be starting here, over 1, up 3. Or you could have gone over 1, down 3. Either way, you're going to have this one's a negative 1 to here. Okay, from here to here would be over negative 1, up 3. Bingo. And then we went positive 1, down 3. So whether you have, I don't want to confuse you here, whether you have 3 over a negative 1 or you have negative 3 over a positive 1, what's the slope going to be? Still a negative 3, and it's going to look like this. How many got that? Good. Okay, try another one. Y equals 2/3 x plus 1. Y equals 2/3 x plus 1. What am I going to do first? Find my intercept. Very good. How do I find the intercept? Make x 0. So if x is 0, then I have, do I have to keep doing this or are you guys getting it? I can just cover that up, right? Because that's no longer there. So what's y equal to? Y equals 1, right there. When x is 0, y is 1. All right? We've got that. So now we want to find the slope. What's the slope? Positive or negative? Positive or negative? Positive. So it's going to be going this way. We can drop this into our triangle. What's the rise? Top number? 2. What's the run? 3. So we're going to start at this point. We're going to go over 3 and up 2. Over 3, up 2. So what does our line look like? That help? Okay. You're just getting warmed up. Let's try another one. Y equals 2x minus 1. Y equals 2x minus 1. If x is 0, what's our intercept? Negative 1. So we've got right here, negative 1. What's our slope? 2 over 1. So our triangle is going to be over 1, up 2. Over 1, up 2. So we start here, go over 1, up 2. Over 1, up 2. How many of you had that? Good. All right. Y equals negative 4/5 x. Y equals negative 4/5 x. What's wrong with this problem? What looks, not what's wrong, what looks different with this problem? There's no intercept, or is there? What do you think it is? Because we could put a 0 in there, right, and still be the same thing, because when x is 0, y is 0. That means it goes through the origin at the point 0, 0, right? Okay, slope, positive or negative? So lean forward or lean backwards? Backwards. So it's going to be somewhere over here. Now let's draw our triangle. 4/5. That means that's a 4 and that's a 5, right? Except it's going to be going backwards like this. So maybe it's -4 like that. So let's start right here. And let's go, what am I doing? Let's go this way. Let's go over this way, -5, and up here 4. Would that be -4/5? So we've got to go over 1, 2, 3, 4, 5, and up 1, 2, 3, 4. And we draw it through here, and it goes on in both directions. So it looks like that. How are we doing? Okay. Now that you're experts, we got one tricky stuff here. And I will confess that I still forget these. And I plot points whenever I forget just to reinforce what I'm going to do. What do you think the slope would be? Let's start here again. Is that slope positive or negative?
Positive.
Is it steep?
Yes.
So would the number be what? What would the slope be here? Guess. 3 or 4 or 5 or 6? Okay. How about this? Steeper? How about this? So what's my slope here? 100? How about this? 200? What's it approaching? As I get closer and closer to being straight up and down, it's approaching infinity, isn't it? It's a really steep slope. Okay, how about this slope? What's this? Well, it's like over 4, up 4, probably 1. How about this slope? It's like a fraction now. Because look, this would be up 3 over 6. 3, 6 would be a half. This would be like up 1 over 6, 1/6. What's this getting closer to? Because that's what I want to know now is what's the slope of a flat line? And what do you think it should be? It should be 0. And let's check it, okay? And the only way I know to do it, if you forget, is just to plot points. But what point is that right there? 0, 3. What point is right here? What is it? It's -2, 3. Okay, what point is over here? 4, 3, right? Get that? What do all those points have in common? Well, look at these points. What number do they have in common?
3.
Which part is the 3, the x part or the y part? The y part. And so what this line is, everywhere along this line, y equals 3. And if you want to think of it in terms of slope, let's go back to our formula. Y equals mx plus b. We know that it crosses at 3, right? So that would be the intercept. What's the slope? 0. Very good. So what's 0 times x?
0.
And so that's how you draw that. That line is y equals 3. Everywhere along there, there is no slope. It's 0, so you have no slope. You just have y equals 3. So draw me this line, y equals -5. What would that one look like? Everywhere along this line, y should be -5, and because there's no slope, it's 0, it should be it should be flat, right? Okay. So if this is y equals 3, what should y equals -5 look like? Okay. So maybe like right here? I agree. You're right. But you know what happens? Sometimes I forget. And so let's say that somebody gave me a problem and they wrote this line on here and they said, what's the equation of that line? I'd say, well, you know, I can't remember. I'm always forgetting this. So I might draw a couple points. I might put a point here, point here, point here. And I'd say, okay, that's -2, -5, 0, -5, 4, -5. And when I had -2, -5, 0, -5, 4, -5, what would I notice? Everywhere along there, y is -5. Bingo. So if you forget that this is a 0 slope and this is y, and which one's y, which one's x, just put some points in and look for the pattern. Okay? Now that you guys are all whiz kids, let me give you another one. What's the slope of this line? I mean, what's the equation of this line? What do you think? Well, you guys are smart. I never would have got that. You're right. It's x equals 1. If you forget, what do? Pick some points. Let's pick this point. Let's pick this point and this point. And this is over 1 up 3. Over 1 up 3. Over 1 up 0. Over 1 down 2. Right? So what do they have in common? They all have x equals 1. Now, remember what I said about the slope before? What is the slope of this line? Well, let's just take it from 2 points and see. From here to here, what's the rise? 3. What's the over part? Oh, what's 3 divided by 0? It's not 0. It's undefined. And you remember we said we were getting closer to infinity, and infinity is undefined. I don't know if that's all the reason, but you can't divide anything by 0, okay? You can have, remember the slope of this line here? What's this, how far over? From here to here. It's over 6. How far up? 0, right? So that's why the slope of this, 0 divided by 6, is 0. So this slope is 0, but this slope is no such thing. It's undefined. But the line is described as everywhere along this line, x equals 1. What would this one be right here? What do you think? What's the one thing that these have in common? All these, this point and this point and this point. X is -4. So if someone says to you, draw this line, x equals -4, you just go over, boom. Draw a line like that. Okay? So now you know how, if I give you lines, to find the little triangles and read the intercept to draw the slope-intercept formula. And if you're given the slope-intercept formula, then you can go back and draw the line. So you feel totally confident with this? Maybe not after watching one video, but maybe after you do lots of practice pages, you'll feel better. And that's why you have practice pages, because it's one thing to go, oh, I understand it. Another thing to practice it over and over until you really get it. This lesson, we've got a couple things going on. And so I would like to encourage you to perhaps divide and conquer. Now, if these different topics, I don't think they're going to be that rough, but if you find one topic that's a little tougher than another one, just stop right there and do some problems from the practice sheets on that topic, and then come back and do the rest of the problems, okay? So we're going to do 3 different things in this lesson. One's not much of a stretch, and 2 is new, and then 1 we're going to pull a bunch of things together that we've been doing, all right? So the first thing is, I've got 3 lines that I have drawn. I mean, I haven't drawn them. I've written them in the slope-intercept formula. They have a slope and an intercept. What do you notice about these 3 lines? Yes? They all have 2/3. What is the 2/3? Is that the intercept or the slope? That's the slope. So what would you expect if you were to draw these on your graph paper that you now have? How would you draw these lines? What do you think is going to happen when I draw them? What do you think is going to happen? If I draw these three lines, what are they going to look like? Like one line going wee wall, one line going here and all that? What are they going to look like? What do you think? Parallel. Now, why would you think they'd be parallel? Which I think is a pretty good answer, but keep going. Because they have the same slope, right? The only thing different is their intercepts. So let's try to draw this one. The slope is 2 over 3, 2/3. So that's going to be over 3 up 2, right? And it starts at, with x is 0, y is 2. So it's over 3 and up 2. So that's the first line, which we'll just draw like this. Okay, now y equals 2/3 x plus, what's the intercept for the second one? 0, which means it goes through the origin, because if x is 0, y is 0, so that's the point 0, 0, and it's going to have the same slope, though, over 3 up 2. So that would look like this. Okay, let's try the next one. What's the slope? Whoop. Same slope. What's the intercept? If x is 0, what's y? Anybody? -5. That would be down here. And that's going to look like over 3 up 2, over 3 up 2. You see that? So do you think those lines look parallel? Yes, absolutely. The only thing that's different is they have different intercepts, but they have the same slope, so they're going to be parallel. Okay? Now, I'm going to draw 3 more slope-intercept things. Y equals -3/4 x plus 2. Y equals -3/4 x minus 1. Y equals -3/4 x minus 4. Okay, how are we going to draw these 3 lines? But before we do, we're going to think, right? So what's the same in all these 3 lines? Everybody. Slope. Slope is the same. So if they have the same slope, -3/4, -3/4, -3/4, they're going to be parallel. Very good. What's different about these 3 lines? Yes. Where they intercept or intersect the y-axis. And we find that by making x 0. So what's that one? Y equals 2. How about this one? Y equals -1. How about this one? Y equals -4. Because when x is 0, y is 2. When x is 0, y is -1. So we have these points, 0, 2, 0, -1, 0, -4. Okay? Now, what's the slope look like? Positive or negative? Negative. So it's going to be going this direction, and it's over 4 and down 3. Or we could put over 3 and down 4. It doesn't make any difference, right? So it's going to look like this. It's going to be a triangle going this direction, right? Because it's -4, +3, -3/4. Or we could have said, well, we could go over this way 4 and down 3. Either way will work. It's still the same line. This would be the same line. This would be the same line. You got that? So if they have the same slope, they are parallel. Good. That's not too tough, was it? We had that similar things before. Okay, this next section is going to be pretty much pure algebra. And let me tell you why you need to learn it first. So far, we've been using y equals something x plus something, right? And that's the slope-intercept formula. Do you like the slope-intercept formula? Have you made friends with him yet? I'm going to use that expression because my uncle was telling me the other day that when my cousin was struggling with math, he said you need to learn to make friends with it. And she later became a math major. And now she works for Microsoft as a, last time I checked, was like a consultant. She's pretty sharp in math. So don't fight math. Just become buddies with it. Okay, the slope-intercept formula is really easy because as soon as you see y equals the m, you know what the triangle is going to look like, right? And as soon as you see the b, you know where it's going to go through the y-axis. So we like that. But what if somebody gives you something like this? 2x plus 3y equals 6. Is that in the slope-intercept formula? How are you going to graph that? That's really tough now, right? So what we're going to work on is this, by the way, is called the standard form of an equation of a line. Okay? It's different from a slope-intercept, but it still has a y, it still has an x, it still has a number. It's just that they're in different places. It's the same numbers, they're in different places. So let's start with this one right now. I'm going to do several examples. Y equals 4/5 x plus 2. And we're going to go both ways. This one is our old friend slope-intercept. But I want to make this so somehow it looks like what I had a minute ago, something x plus something y equals c. So we still have the x, we still have the y, and we still have the c. I like to think of c as a constant, okay? So how am I going to change this to look like this? What do you think? Any ideas? Yes?
Get the x and the y on the same side.
Okay, because this one has the x and the y both on the left, and here's got the x over here. So how am I going to move the x over to here?
Subtract 4/5 on this side.
Yeah, because I'm not really moving anything. I'm adding the same thing to both sides or subtracting the same thing from both sides. So if I subtract both sides from minus 4/5 x, right, then this becomes 0. Now I have y minus 4/5 x equals 2. Ooh, that looks pretty close. I've got the c, I've got the something times x, and I've got the some. Uh-oh, I got the x here first and the y here. So what should I do now? Can I switch the order? No problem. So I got negative 4/5 x plus y equals 2. Something x plus something y equals 2. Good. Do you see any fractions up here? I don't want fractions. So what can I multiply times this whole thing that would make it so there's no fraction? What? 5. Remember what we studied a long time ago about least common multiple? So we can multiply this side by 5 and this side by 5. So basically we're multiplying 5 times everything. 5 times this, they would divide out. So we got negative 4x plus 5y equals 10. Because 5 times this is this, 5 times this is this, 5 times this is this. Oh, do we call that the distributive property? Do you see how we're starting to pool everything together? All right. This right here is the standard form of an equation. It's the same as this. It's just in a different form. If I gave you this, could you go back and make it into that? We'll do that in a minute. Okay, so here's another one for you. Y equals negative 2x minus 1. Try this one on yourself. Y equals negative 2x minus 1. And I want to put all the x's and y's on one side. I want to get rid of any fractions. So it looks like something x plus something y equals c. Okay, if you're watching this at home, pause it, work on it, and then I'm going to keep going. Okay, the first thing I want to do is I want to put this x over here. So I'm going to add 2x, right? A positive 2x, because that'll make that 0. And the 2x will now show up over here. 2x added to both sides. I've got 2x plus y equals minus 1. Okay, now what do? Smile, because I'm done. That's the easy one, see, because I've got the x, and I've got the y, and I've got the c. That's all there is, okay? That's a piece of cake. Let's give you a little trickier one now. Y equals 5/3 x. Y equals 5/3 x. Okay, now, I could do this a couple different ways, and let me just encourage you. We do have answer keys, and we have solutions for all the problems, and we work it all out. There are usually many different ways to solve the same problem. So if you don't do it exactly like me, you could be exactly right. I just happen to choose a different way, okay? So there's no one single way to solve a problem. There's usually one single answer, but there's different ways of getting there. So encourage yourself if you did it a different way. I could subtract the 5/3 x, couldn't I, first? Or I could multiply both sides by what first? What? 3. So if I multiply the whole thing, or both sides by 3, this becomes 3y. The 3 and the 3 here divide out, so we've got 5x, right? Now what? Subtract 5x from both sides. So if I subtract 5x from both sides, I've got negative 5x plus 3y equals what? 0. Now what do I do? Smile, right? Okay, because we're done. Or we could give the victory sign or something, because something x, something y, 0. Get that okay? Okay, now we're going to go backwards. So here's one for you to try. 2x plus 3y equals 6. 2x plus 3y equals 6. That's in the standard form of an equation. Really hard to graph like this, though. So we want to change it to our old buddy, y equals mx plus b. So what do you think we ought to do first? Let's put the x. Boy, this x is always moving around, isn't it? Okay? So we're going to put the x over here. So we're going to subtract 2 x's from both sides. And now we've got 3y equals minus 2x plus 6. Good. Uh-oh, we got y only has a coefficient of 1. This has a coefficient of 3. So what do we do now? Divide by 3, or multiply by a third. It's the same thing. So we divide this whole thing by 3, this by 3, this by 3. We've got now, that's 1, y equals negative 2/3 x plus 2. Which one would you rather graph? This one or this one? This one, right? And that's why we do this, okay? But you have the standard form and you have the slope-intercept form. Here's another one. Negative x minus 2y equals 4. Negative x minus 2y equals 4. And now what we're doing is we're going to add x to both sides. We have negative 2y equals x plus 4. We're going to divide not only by 2, we're going to divide it by what? Negative 2, because we want a positive y. So now we have y equals negative 1/2 x minus 2. Somebody got that one right. Good. How would you graph that? First find the intercept, then do the slope, positive, negative. You're good at this, right? Okay. So practice those. Now we're going to pull together a bunch of things. I'm going to give you 2 points. Negative 1, 4. If you have your graph paper, this is a good one to try. And 1, 0. Here's 2 points. I want to have you draw the line, give me the slope-intercept formula for the line, and then the standard form of an equation for the line. Pulling it all together. So if you're watching this, hit pause, try it, and then compare your answer. Negative 1, 4, 1, 0. So I can see right from the start that my slope's going to be negative. Okay, so what I'm going to do first is I'm going to estimate the slope of the line. It's negative. Then I'm going to make a triangle, and I'm going to find my slope. And it's over 2, or negative 2, up 4. So my slope is 4 over negative 2 equals negative 2. Okay? After I've done this, I'm going to find the intercept. And I can see the intercept is right here, which is what? 2. So b equals 2. So what I have is y equals minus 2x plus 2. So that's my slope-intercept formula. I'm almost home. Now I'm going to change this, though, to the standard form of an equation by adding 2 x's to both sides. So I've got 2x plus y equals 2. And there's my standard form of an equation. This is my slope-intercept formula. And there's my graph. Who did that one okay? You're whiz kids. You might even get lunch. Okay? Now let's try one more. Well, let's do this one a little tougher. Negative 6, 4 is the first point. Negative 6, 4. And the second point is 3, negative 2. Same thing. Find your slope, find your intercept, find a slope-intercept form, change it to the standard form of an equation. So here we go. Negative 6, 4. So negative 6, 4, 3, negative 2. And connect the little dots here. And it looks like my triangle is over negative 9 and up 6. So it looks like my slope is 6 over negative 9, which reduces to negative 2/3. The intercept, it goes right through the origin, so the intercept is 0. So I've got y equals negative 2/3 x plus 0, so we'll just leave it. Okay, slope-intercept form, done. Standard form is what do you want to do? You want to multiply first or move first? We can do either one. You want to move it first? Okay, so we'll move the x over here by adding the opposite of that, which is positive 2/3 x. Positive 2/3 x. So I've got 2/3 x plus y equals 0. How do I get rid of the 3 in the denominator? Multiply by 3, because really that means divided by 3, opposite dividing, multiplying. Everything by 3. These cancel here, 2x, 3 times y, we distributed. 3 times 0 is 0. What's this called? Standard form of an equation. Feel comfortable with that? Boy, you've learned a lot. You're doing really well. Okay, that's it. So practice those things until you feel comfortable with that, and then we're going to do something different in the next lesson. Okay, I have 2 lines drawn on our graph. How would you describe these 2 lines to me? Yes?
They're intersecting lines.
They're intersecting lines. Very good. What else? Perpendicular. What's a perpendicular line? Yeah.
They don't touch, but they're the same slope.
No, that's parallel. Parallels, they don't touch and have same slope. Perpendicular is the opposite because they do intersect. And what kind of angle do they form when they intersect? Anybody? They make a right angle. So what do we have here that's got a right angle on it? We could take one of these little blocks maybe. We could stick it up here. Is that a right angle? Okay. Now, there's more to it though, because you can see that in the drawing, but what would it look like algebraically? When I say algebraically, what do I mean? Well, this is geometrically because we can see it, right? It shapes its lines in a plane. But algebraically with slopes of lines. So what do you think the slope of this line would be? And what do you think the slope of this line would be? Can you figure it out? What do we have to do to find a slope? Make a triangle. Okay, so let's make a triangle. Now, whenever I'm looking for a triangle, I'm looking for points that lie right on the intersection of the points. I wouldn't pick this point right here because I don't know if that's a half or a third or what, right? So when in doubt, I could go all the way out here, or I could make this little one right here. Let's try this little one. What's my run? How far over? 3. How far up? 2. So we're going to call this slope, of line A, we'll call this line B. So the slope of line A is 2/3, right? Okay, now, that's a positive or a negative? Positive. What's the slope of this line? Negative. Okay, let's make a little triangle. We'll go from this point to this point. How far over?
2.
Well, or -2. How far up? 3. So the slope, now this is A, so the slope of B is what?
3 over -2.
3 over -2, or just -3/2. Now look at these numbers, and what do you notice? They're the opposite. And when you have fractions that are the opposite, the fancy word is reciprocal. Did you ever hear that word? Boy, we have to learn how to spell these words. How do you spell perpendicular? Go ahead, try. P-E-R. You're good so far. P. Somebody said I, somebody said E. It's P-E-N. It's perpen. Okay, dicular. D-I-C-U-L-A-R. That's pretty easy. So 2 E's. How about reciprocal? How do you spell that? R-E-C-I-P-R-O-C-A-L. Reciprocal. Okay. Now, it's in the book. But the reciprocal means if you have 2/3, you flip it and it would be 3/2. But not only is it a reciprocal, it's the opposite sign. This one is positive, this one is negative. You see that? So 2 lines that have slopes that are the negative reciprocal are going to be perpendicular. 2 lines that have the same slope are parallel, right? So either parallel line, same slope, perpendicular, negative reciprocal. Okay, I'm going to draw 2 more lines, and I want you to see if you can find out if they are negative reciprocals. Okay, so the first one is going to start right here, going to go through here, okay? And the next one's going to go through the origin, okay? So the first line, what do you think the slope of this line is? What do you think? Well, wait, hold on a second. Let's go back. Find the slope of this line here first. So let's try to find this. We're going to call this C. We'll call this D. What's the slope of this line? Positive or negative? Negative. Okay. Well, let's make the little triangle here. Looks like we have to go all the way over to here to get a nice solid one. How far from here to here?
4.
-4, +2. So the slope of C would be -2/4, which would reduce to what? -1/2. What should the slope of this one be? Just for a second, I want you to think about that. What should it be? Well, we should flip it and change the sign, right? So it should be a +2/1 or +2. What is the intercept for line C? Where does it intercept the y-axis? 2, right there. Okay, so the slope is this, the B is the intercept, so can we write an equation for that? With the slope-intercept formula, which should be y equals mx plus b. Okay, what's m? -1/2, right? What's the intercept? 2. So this right here is line C right here. Okay? So what should be the intercept slope-intercept formula for this line? Okay, now our slope should be the negative reciprocal, so it should be a +2/1 x. Okay, where's the intercept? That goes right through the origin, and so that would be +0, which is just nothing. So we have y equals 2x. So this line and this line are what? I'm about to cough, so I have trouble saying it. Perpendicular. So this is perpendicular because the slope is a negative reciprocal. How many lines are perpendicular to this line here? Well, could I have one here? Here, here, here? Infinite amount. But there's only one that goes through the origin, and so that would be this one. Okay? Let's try another one. There, got the cough out of me. Okay, now I'm going to find a slope of line F that goes through this point right here, and it goes down to this point right here, all the way. Oh boy, can I do that straight? Let's see. Okay. Now, what's the slope of this line right here? Well, let's make a triangle. It looks like we can go from here to here. So how far over? 3. How far up? 1, 2, 3, 4. So our slope is positive, leaning forward. So it's y equals 4/3 x. What's the intercept? -2. Okay. Now what we want to find is the slope of a line that goes through this same point right here that's the perpendicular to this line. How are we going to do it? Go ahead. Okay, I'm going to take this. What's the opposite reciprocal? I'm sorry, reciprocal is already opposite. I have to find the reciprocal, which would be 3/4. What else? This is positive, so this has got to be negative. Okay, good. All right? Now, where does it go through? Which point? It goes through this point, so that turns out that's going to be our intercept. So what's the intercept here? -2. Let's draw it and see. It's -3/4, so that means it's boom, boom. So it can be -4 this way, up 3 this way, and it goes down like this. How's that look? That it? Okay. The key is right here, though, isn't it? The negative reciprocal for perpendicular line. That's it. And now that we have found the slope-intercept form, are you remembering how to change that to the standard form of an equation? How would you do that? Okay, you want to put the x over here first. So we'd have y, we got to add 3/4 x to both sides, right, to make that 0. So we'd have 3/4 x plus y equals -2. But we don't want fractions. How do we get rid of the fraction? Multiply by a 4. Both sides are all the components multiplied by 4. And so this would give us 3x. Then we'd have 4 times y, 4y. 4 times -2, -8. So that would be the standard form of the equation of a line. We're going to just take things up. If you notice, we're just going to take each lesson up a notch from where we were before. Now this time, I'm going to give you the slope and a point. And I want you to, and you can do it even without drawing it, but we're going to do both. We're going to build it, we're going to draw it, and we're going to write it at the same time. But at the end of this lesson, we're going to be able to solve these without even drawing them. But I like to draw them because it helps me to make sense of what I'm writing. Okay, so the first thing we're going to do is, this is a point. How would I find this point 1, 2? Go over 1, up 2. Okay, now that point is in our line. And the line has a slope of 3. So how would I draw that? Starting there, what would I do with 3? What's 3 mean? It's really 3 over 1, isn't it? So I'm going to go over 1 and up 3. And I could go in this direction as well. And I'm going to draw a line like so. Okay? Can we write an equation to represent this line? Well, we've got y equals mx plus b. So far, this is pretty easy. We represent the slope as 3. Okay, this is the tricky part. Now I can look over here at my drawing and I can see, I think, that my intercept is -1. Would you agree with that? So I should have y equals 3x minus 1. That's what I'm thinking I'm going to get. But here's how you know for sure. You take this point and you replace it into the equation. So this is x, this is y. So for the x, I'm going to put the 1. So 3 times 1. For the y, I'm going to put the 2 plus b. Little tip here. People often tell me I can do a lot of math in my mind, because I can, and I like to do it in my mind. But whenever I'm doing equations, I don't want to put too much up here because I make mistakes down here. So usually I put in the information in parentheses and then start working it. So I've got 2 equals 3 plus b. If I subtract 3 from both sides, now I have 0 over here, and I have 2 minus 3 is what? -1. And that's what we thought it was going to be, and it turns out it is. So our equation of our line is, in the slope-intercept formula, like that. Could you put that into the standard form for me? What would I do first? Put the x over here, -3x plus y equals -1, and smile because we're done, right? Okay, so there you go. So if I give you the slope and a point, you first plot the point, make a little triangle to find your slope. You're going to be pretty close to finding your intercept, but you don't know for sure until you put this number in the equation to find out your intercept. Once you have your slope and your intercept, then you can either leave it in this form or change it to this form. Comfortable with that? Okay, now we're going to get a little tougher. This is what we do, right? One more little step. I'm not going to give you the slope. I'm going to give you 2 points. If you've got graph paper, try this one. Here are the points. 1, 1, and -1, 5. Points are 1, 1, and -1, 5. So what do you think your first step would be? Yeah, well, we need to find a slope, right? But we don't know what a slope is until we plot our points. So we're going to put in 1, 1, and -1, 5. So right away, what's our slope look like? Positive or negative? Negative, okay. And so we can draw our line. Where do we think our intercept's going to be by drawing? Probably right there at 3. It looks pretty accurate too. But let's go back and solve it for sure. First thing, slope is going to be, make our triangle, -2 plus 4. So we've got -2 here plus 4 here. 4 divided by -2 is -2. So now we've got y equals -2x plus b. How do I find my b without looking? What do you think? I take either one of these points and put it in the equation, because then I'll have a number here, a number here, a number here, and when I'm all done, I'll have b equals some number. Okay, so which point would you like to work with? 1, 1 or -1, 5? Why 1, 1? Because it's easier. Okay, it's not negative. So but you could do either one. So I'm going to put in a 1 here and a 1 here. So now we have 1 equals -2 plus b. Add 2 to both sides. 3 equals b. We thought so, but we weren't positive. So now our slope-intercept form is y equals -2x plus 3. Could you make this into the standard form? How would you do it? Add 2x to both sides, 2x, piece of cake, right? Okay. Is everybody happy so far? Because now it gets a little confusing unless you just stop and think about it. Now we're going to do it without drawing. So we're going to just slide our little board off to the side. Well, we'll use it a little bit. Baked out. Here you go. Here's 2 points. But by the time we're done, we won't need that board. The points are 5, 3, and 2, negative 4. 2, negative 4, and 5, 3. 2, negative 4, and over 5, up 3. Okay, what are we going to do first? Well, if we were doing it with our board and we're all happy and we can draw this, we can see we've got a positive slope. We can see that it's going to intercept way down here somewhere, right? So we can get pretty close by estimating it. But I want you to look at this triangle first. What's the x-coordinate right here? What's my x-coordinate? Okay, no, just the x, the 2, right? What's my x-coordinate here? How far over? 5. Okay, now look. How far from a line 2 to a line 5? How far going this way? What's our horizontal part going to be? Now, could you have told me that, though, just by looking at these two numbers up here? How far from 2 to 5? 3, right? So you can find the x part, you might say the run part. You can find that just by looking at these 2 points, couldn't you? Okay, what's the y? How far from here all the way up here? See, if we were to draw a triangle, right? How far from the y part here to the y part up here? What's my y? Negative 4, right? And my other y is 3. Okay, so how far from negative 4 to positive 3? We're just looking at the up part now. 7. So what's our slope going to be? 7/3. But you know, you could have looked at that and said, the difference between negative 4 and 3 is what? 7. Do you get that? So what we're going to do is we're going to call this point 1. We're going to call this point 2. Now we're going to simply subtract point 2 minus point 1. 5 minus 2 will give us a 3. 3 minus a minus 4. And we're going to write it, and this is where it gets confusing. This is x and this is y, correct? But because it's point 1, we're going to put little 1s here. This is point 2, so we're going to put little 2s here. Okay, so what I'm going to do is I'm going to subtract this minus this. See, 5 minus the 2 will give me the 3. 3 minus a minus 4 is 3 plus 4, which is what? 7. Okay, so we're going to say this. Our rise is y2 minus y1. Our run is x2 minus x1. You still with me? Okay. Maybe I'm the only one that gets confused by this stuff. You guys are doing fine. So now let's put the numbers in. X sub 2 is 5, right? What was x sub 1? 2. And didn't we subtract 5 minus 2 to get what? 3. Okay. Y sub 2, this number is 3 minus y sub 1, which is what? Minus 4. And what's 3 minus a minus 4? 3 plus 4, which is 7. So all you do is you put the first point here minus the second point here to get the 7/3. So what's our slope? 7/3. So we put in y equals 7/3 x plus b. How do we find b? Because b is off my graph here, right? I need to use some algebra now because I'm running out of graphing space. Are you sad? Here we go. Which number do you want to use to put in here? 5/3. Why did you, let's vote. Who wants 5/3 or 5 and 3? Who wants this one? That's right. Why do you shy away from this one? Negative 4. Okay, let's try the 5 and the 3. X is 5, so 7/3 times 5. Y is 3 plus b. Woo! Look at all this work. What's 5 times 7? 35 divided by 3. Very good. 11 2/3. I did it last night. Okay. And here you got 3 plus b. But I got to subtract 11 2/3 from both sides. So now I've got negative 8 2/3 equals b. Is that about right? 6, 7, 8 2/3. Pretty close, right? So if I'd have got positive 8 2/3, I'd have known I was going to be off. But because you draw it, it helps you to estimate your answer. You get that okay? So what do we do first? You could plot the points, you could find your triangle, or you can use some algebra, and you could make this your first point, second point, subtract second point minus the first point. So this is our first point, second point. Now here's one tip. Make sure that you stick. See, this one I did 3 minus this, 3 minus this. Then I did 5 minus this, 5 minus this. I went 0.2 minus 0.1. I've seen sometimes kids make mistakes though, because what they do is they put 3 minus and minus 4, and then they might put 2 minus 5. Make sure you're subtracting the same direction, because then we get negative 7/3. Is our slope negative 7/3? No, that would be an indicator that we're off. Okay. All right. So there you are. So now you're able to solve an equation even without drawing it. So this next one, we're not going to draw it at all. Here's the points. Point 1, 1, 1. Point 2, negative 1, 5. Okay, what are we going to do first? We have to find our what? Slope. Okay, so the slope, we're going to make this 0.1, this 0.2, and here's what we do. We're going to subtract this minus this. So we're going to do the x's and then the y's. But here's how you write it. Y sub 2 minus y sub 1, x sub 2 minus x sub 1. Let's put these in here. X sub 1, y sub 1. X sub 2, y. Why do I keep saying sub? Am I hungry? Am I a Navy guy? No. What does sub mean? Subscript. A subscript is one that's below the line. So we call it sub when you read it. So y sub 2 minus y sub 1. Okay, what is y sub 2? 5. What's y sub 1? 1. What's x sub 2? Negative 1. What's y or x sub 1? 1. Okay, here we go. What's 5 minus 1? What's negative 1 minus 1? Negative 2. So what's our slope? Negative 2. So we've got y equals negative 2x plus b. Good. Okay, now, which number do you want to use? This one or this one? I know we all want the easy one. I'm going to try the hard one this time just to be difficult. Okay? So we're going to put in negative 1 for x. We're going to put in 5 for y. Okay, 5 equals, what's a negative 2 times a negative 1? Positive 2, good, plus b. Subtract 2 from both sides, b equals 3. So what I think we've got for our slope-intercept form is y equals, what was our slope? Minus 2x plus 3. Let's just now check it by graphing it, see how we did. 1, 1 is right here. Negative 1, oh, we already did this one before, didn't we? And there it is. It's a negative 2, because it's over 1, up 2, over 1, up 2. And it goes through the point, 0, 3. When x is 0, y is 3. We got it. What did we not do now? Change it to standard form. How do we do that? Add 2x, so piece of cake. How's that? Let me use a little bit of language that you maybe never saw before. When you subtract y2 minus y sub 1 and x sub 2 minus x sub 1, you know what you're finding? You're finding the change in x and the change in y. And the change is often in mathematics is described with a delta sign. This is, who knows Greek alphabet? Alpha, beta, gamma, delta. And that's a capital delta. It's a triangle. So this means the change in x. And you're finding the change in x, remember from 2 to 5, the change in x by subtracting. And then sometimes we even use this. dy dx. What do you think the d stands for? Delta, because it changed the change in y divided by the change in x. And if you're not careful, you're going to find yourself falling right into calculus. That's what calculus is. It's the change of two different variables. So graphing lines, really, we're getting ready for calculus. Aren't you excited? You can hardly sit still. What is different about this lesson? What do you see up on the board? What's the same? What do you see? What looks the same? Slope, intercept, slope, intercept, slope, intercept, slope, intercept. What looks different? Oh, greater than, and equal, greater than, equal. So there's really 4 different symbols up here, aren't there? And these are called inequalities because they're not equal. Okay? But we're going to figure out how to graph them. And I will tell you right up front, I hardly ever remember how to do this except by plotting points. So I'm going to encourage you to do the same thing. Now, if you grab this real fast, good for you. But here's what we're going to do first. We're going to forget about the inequalities, and we're just going to graph this line. Okay? So what's the slope-intercept form? I mean the intercept. What's the intercept? If x is 0, what's y? Okay, so it's going to start here, and then what's our slope? Positive or negative? Positive, and it's over 1 up 2, right? So it's going to look something like this. It's going to be this line going from here all the way like that. Now, on these kind of graphs, so go ahead and draw this on your graph paper, because the hardest part is now remembering that this is an equation, except it's not equal anymore, but it's still an expression that we can graph. So the first thing is, if this was y equals 2x minus 3, it would look just like this line, right? Okay, now, if you have any brain energy left, I want you to think with me now. Do you realize that any point along this line would make both of these sides equal? See, sometimes when you start doing a whole bunch of math, you forget why you're doing it, is that it's real things. So let's pick a point. Let's pick a point right here. Let's pick a point here. Let's pick a point here. Pick a point here. Any one of these points, I'm going to maintain that if I put it in this equation, it's going to make it work. Let's try it. So I have y equals 2x minus 3. So let's put it this point here. 1, negative 1. So x is 1, y is negative 1. Let's try it. You think that's going to work? 2 times 1 is what? What's 2 minus 3? Negative 1. Negative 1 equals negative 1? Yeah, that one works. Let's try this one. Over 2 up 1. So this time we're going to put 2 and 1. 2 times 2 is what? What's 4 minus 3? 1. 1. You getting the point? Point. Another joke. Okay. I could keep doing this all day. I could put in 1.5 and get 0, I think. Let's try it. What's 2 times 1.5? 3. And what's 3 minus 3? You see? Every single point along this line, if I put it in this equation, would work. That's what we started with, remember? Loaves and bread and lobsters per trap and dollars per box and all that kind of stuff. So any one of these points, if you fits this equation. So what about a point out here? this is where we get into greater than or less than. So we're going to do the first one right here. First of all, would any of these points, now this is a hard part, would any of these points here fit in here? Why not? They'd be equal. It wouldn't be larger. So if I was to take this point again, 1, -1, and put it in here, -1 greater than 2 times 1 is 2 minus 3. Is that true? Absolutely not. That's equal, not greater than. So what we do is we put little dashes in this line to show that it doesn't include the line. If you see dashes, it means it doesn't include the line. All right. Now, what about these points up here, or all of these points over here? Which one of these, if we put it in here, would make it true? Who thinks they know? How many say this side? How many say this side? How many don't know? So how are we going to find out? We're just going to pick some points. So which do you think would be the easiest point out of all these to put into here? Yeah, the one I just touched before I got done. That's origin, 0, 0. So let's try it. Let's put in 0 for x, 0 for y. Is 0 greater than -3? Think about it. Would you rather owe somebody $3 or owe them nothing? And when you think about a number line, 0 is further to the right, isn't it, than -3? So 0 is greater than -3. So that's a good one. Just to make sure we didn't mess up, let's pick a number over here. You pick one. 2, 2? That's still here. 2, -2. All right. So we'll put in a 2 here and a -2 here. What's 2 times 2? Okay, let's try that one more time. 2 times 2 is 4. -3, 1. We're working on our after lunch sleepies. And this was -2. Is -2 greater than 1? No. So that's not it. And it turns out this is it. So I'm not going to do this now, but it's in your book. I would shade this whole side. So any point over here would make this equation true. Okay. So for the first equation, y is greater than 2x minus 3, it would look like everything over here. What if it was this? Greater than and equal to it. What do you think? The line wouldn't be dashed because it would include all of these points, because what this is saying is y is greater than 2x minus 3 and y is equal to 2x minus 3. So this one would make it a solid line. This would make it everything up here. So when you see this expression, you see the greater than sign and the equal sign. You really should say this: y is greater than or equal to 2x minus 3. Is that okay? So now we're going to do the less than one, and you can probably figure this out. Y is less than 2x minus 3. Because I think if this was greater than, it should be down here. So let's pick one point. Which point do you want? You pick a point. It's your turn. Any point over here. 3, -4. All right, very good. We'll try that one. So we're going to put 3 in for x, -4 in for y. -4 is less than 2 times 3 is 6, minus 3 would be 3. Is that true? -4 is less than 3?
Yes.
Yes. So it would be, this graph would be all of this shaded. But again, if you don't know, just plot points. We could try the origin again just to double check it. Put the 0 in here. Let's put a 0 here and a 0 here. What's 2 times 0? 0 minus 3, so we get minus 3. Is 0 less than minus 3? No. Okay? So it turns out that we were right. So this is less than. Now let's go over here. And what does this symbol mean? Who can read that for me? Less than or equal to. So it's just a combination. So this would be y is less than 2x minus 3. Y is equal to 2x minus 3. It's either one of those. So what would be different in my graph? It would have the line shaded in for this and this all shaded in for this. So if you put them together, you'd have the line plus everything to this side. Got that okay? All right. So this is graphing inequalities. And this is kind of tricky. Now, remember, whenever we graph something, we like to have a positive y, don't we? And we like to have y by itself over here in the slope-intercept form. But what if you get something like an equation that says something like, well, here's one right in the book right here. Negative 2y is greater than or equal to 3x plus 6. What am I going to do here? What do you think? Multiply by, or divide by negative 2, right? And then we'd have, the only problem is if you have an inequality, you just can't go multiplying and dividing both sides. It does things to the inequality. And let's just have a little example. Is this true?
Yes.
Okay. Is this true? Okay. If I multiply this by a negative 2, what would happen? Is that true? No. If you multiply or divide by a negative number, you've got to change the sign because it's like the double negative thing, okay? So if I had this equation here and I wanted to put that in the slope-intercept form, okay, I'd like to divide through by 2. Let's do that first. So I've got negative y, 3 halves x plus 3. No problem. But if I multiply through by a negative 1 now, what do I have to do? I'm going to have to flip that sign. So it's y less than or equal to negative 3 halves x minus 3. You see that? And the negative sign would make everything on this side negative, but it's also going to change the sign. So remember that. This is a piece of cake. Once you get it in this form now, you can graph this, pick out what side by plotting some points, shade in one side, shade in the other. If it's got the equal sign, it includes the line. If it doesn't have the equal sign, it's a dotted line. Okay? Now, if you were reading along in your books, which I'm always encouraging you to do, you would know what the next big word is coming. Because we could play hangman again, except, well, you've already beat me twice, and so I've had enough. But if you're reading along with your books, you would know it anyway. The word is simultaneous. What does simultaneous mean? Yes?
At the same time.
At the same time, right. Maybe we should say simultaneous, but it's the same, right? Okay. So what we have here, and let's just review one more time, how many points on this line right here? How many points are there? Let's all try together. 1, 2, 3. Infinite number of points. And any point along that line, I could pick any point and I put it in the equation, it'll work, right? Turns out, which one is which? Well, I don't like it in this form. I need to put the x over here. So y equals minus x plus 3. Which line is that? Is this line 1 or line 2? Line 1, because it's a negative slope. It goes through the intercept 3, and so that's line 1. Okay? Line 2 goes through negative 3, and it has a slope of over 1 up 2, over 1 up 2, so it's this line. Okay, now here's what we're going to do. We're now using, and believe it or not, I've written a book called Stewardship, and in that book, I used this stuff right here to figure out which is the best cell phone plan. In other words, I'm using math to solve real-life problems, okay? So in this particular situation, any point along this line, I could pick any one, and in the book I do that, I pick several points, would fit in here. Let's just pick one, right here. Negative 2, 5. So what's a negative? Negative 2. Positive 2 plus 3 is 5. See, negative 2, 5. It works. Any point along this line, if I put it in this equation, would make it true. You all agree with that? Okay. So the deal is, I can find out that there's only one point that will fit in both of these equations and make it true. There's only one. Which point do you think it is? The point in which they intersect. Right here, over 2, up 1, right? So we can use graphs to find out that there's only one point that when we put it in here will make these equal. Let's try it. So this is over 2, up 1. So we're going to put the 2 in here, put the 1 in here, put the 2 in here, put the 1 in here. Let's try it. 2 times 2 is what? 4. Minus 3. 1 equals 1. It works for line 2. Let's try it here. What's negative 2 plus 3? Negative 2 plus a positive 3? Positive 1. It works for line 1. It is the only point in the universe that will satisfy both of these equations at the same time. So we call this solving simultaneous equations with graphing. And all you have to do is graph them, find at the one point where they intersect, and that point is your solution, which is what when we do, we were finding cell phone plans. We draw 2 lines with the graph of each cell phone plan and find out which one is the best one. Okay? Wasn't that an easy lesson? There you go. Now that you know how to solve a simultaneous equation by graphing, which you can always do that if you want, I'm going to give you a different way to do it. We're going to call it solving simultaneous equations by substitution. Now you can check your work if you want with graphing, but we're going to do y minus x equals 0. And we have another equation which is y minus 3x equals minus 4. Okay, now remember what I'm looking for. I'm looking for one point. I'm looking for one solution. If I was to graph this, I could do that. This real quickly. This would be a line going like this, and this would be a line that would be going like this, and somewhere up in here, there's one point that would satisfy both of these equations at the simultaneous time, at the same time, which is where we get the word simultaneous, right? Okay. So what I want to do is, I'm going to change this equation, and I'm going to change it to make y equals something. So I'm going to take this positive 3x, I'm going to add to both sides, and I'm going to get y equals 3x minus 4. Okay? That's still the same equation. And then everywhere, forget this now, everywhere up in this equation that I have a y, I'm going to put this. So I have a y up here. So instead of putting the y in here, I'm going to say 3x minus 4 minus x equals 0. Okay, now algebraically, what do I want to do when I want to solve for a number, for an answer? I want to have like x equals something, y equals something, right? And the problem is here, I have a y and an x. Here I have a y and negative 3 x's. I've got 2 variables, but all I want is one variable. Okay, I just want something equals a number. Got that? Okay, so what I did was I got rid of a variable because everywhere I had a y, I put in 3x minus 4. So now all I have here is x's and numbers. Make sense? So what I want to do now is just solve. So I've got 3x minus 4 minus x equals 0. 3x and minus x are 2x minus 4 equals 0. Add 4 to both sides. 2x equals 4. X equals 2. I couldn't have done that when I had 2 variables. I can only do that when I have 1 variable. Now, I can take that x equals 2, put it up into here. If x is 2, what's y? This is a tricky one. What minus 2 equals 0? 2. So y must be 2 as well. So it turns out our solution then is, where do we have room to write it? Our solution is if x is 2, y is 2. And if we were to graph that, remember I said the one graph looked like this? y equals x. The other one was negative 4. And it goes right through that point, 2, 2. Okay? So we, without even graphing, were able to find the only solution to these two lines by substituting one of the variables in for another variable. Let's do another one. Unless you want to try it yourself. Here, I'll give you two equations. Here you go. If you're watching, you can write it down and figure it out and then turn it back on. Y equals x minus 1 and y equals 3x plus 1. Those are our two equations. Y equals x minus 1 and y equals 3x plus 1. So what you want to do is you want to substitute, and you can do x's if you want, or you can do y's. I'll do this next one two different ways just so you can see. Pause. Okay, I'm back. So everywhere I have an x minus 1, a y, I can replace it with an x minus 1. So I can put the x minus 1 in right here. Then I could do what? I could subtract 3x from both sides. I get negative 2x over here. I could add 1 to both sides, equals 2. Divide both sides by negative 2, x equals minus 1. If x is minus 1, what's minus 1 minus 1? So y is minus 2, so the answer would be negative 1, negative 2. And that was first by substituting this everywhere I had a y down here, so I'd only have one variable, just x's, then I can solve for x. Once I find x, put it back up in here, find y, I got it. Let's do it differently this time. Let's substitute, let's add 1 to both sides. Okay, now, everywhere I have an x down here in this equation, I'm going to put y plus 1. So y equals 3 times, whoa, I messed up. We got an x. So y equals 3 times y plus 1 plus 1. Is that right? Is there any x's here? No, that's what I want, no x's. So now I've got y equals 3y plus 3, distributive property, plus 1. Y equals 3y plus 4. Subtract 3y, negative 2y equals 4. Divide by negative 2, y equals negative 2. If y is negative 2, x is negative 1. So did it work? Okay, so either way you want to go. You can either substitute x's for y's or y's for x's, but the big picture is you want to get down to one variable and then solve it, pop that number back in, find the other solution, and you've got your point. Okay? Now we're going to do a killer problem. I picked this one from the from the practice sheets, and it's a tough one. Okay, so if you want to try a toughie now, you can go along with me. 2x plus 3y equals 29, and 5x minus y equals 30. Does that look like a fun problem? Remember what we're doing. Each of these could be graphed as a line with infinite solutions, but there's only one solution that is going to equal, that will satisfy both of those. Except, what if the two lines were the same line? What if they were the same line on top of each other? Okay, so I'm assuming these are different lines, and they're going to intersect like that. Okay, there'd be one solution. Or what if they were two parallel lines? And there'd be no solution. But I'm assuming in these problems I'm giving you that there's one solution. So how are we going to do it? Well, this one, I'm going to put the 5x over here. Negative y equals negative 5x plus 30. Have you figured out by now that you could put minus 5x, and if you want to keep doing that the rest of your life, that's fine. But what you really end up doing is you change the side, you change the sign. You notice that? So it's a positive 5x here, it's a negative 5x over here. Then I'm going to divide through by negative 1. So now I've got my value for y. Now I put this up into this monster, 2x plus 3 times 5x minus 30 equals 29. 2x plus 15x minus 90 equals 29. Add these two, 17x. Add 90 to both sides equals 119. X equals what? Looks like 7. Is that right? 7 times that's 49 plus 70. Very good. Then I take this 7, put it up here. What's 5 times 7? So 35 minus something is going to equal 30. What must the something be? 5. So my solution is x is 7, y is 5. So I write it as 7, 5. That's the point at which both of these lines are going to intersect, producing one solution. Got it? So now for your spelling class, we have to learn how to spell substitution and simultaneous. So up to this point, you can solve two simultaneous equations to find your solution by drawing the lines where they intersect, or by substituting one of the variables into the other line equation so you only have one variable, right? Then you get x equals something or y equals something. This is another way we're going to do it. It's called elimination. Aren't these wonderful words? I like these big words. Elimination, substitution, simultaneous. Woo! So here we go. First of all, let me see if I can show you the math involved. Is that correct? Is that true? If I add the same thing to both sides, no, let's do this. Let's make another equation. Okay, can I do that? Could I add these two equations? Yeah, so as long as they're both equal, I can add them, right? Okay, and I have the same thing. Okay, this is where it's going to come in handy. So what if we had this equation? X plus y equals 3, and 2x minus y equals 3. Now remember what we want to do. We want to get it down to one variable. So instead of substituting, we'd like to eliminate one variable. And if we were to add these two equations, what would happen? What's x plus 2x? 3x. What's positive y plus a negative y? Oh, get goosebumps, right? Because that's what we want to do. We want to eliminate one of the variables. So now we have 0. 3 plus 3 is 6. X equals 2. Bingo, right? Now we put the 2 up here for x. What's y going to be? 1. Get that? So you like that? So you don't have to substitute anything. You don't have to draw any pictures. You just add the two equations. One of the variables very nicely was eliminated. So let's try this one now. Y, try this yourself. Y minus x equals 0. Y minus x equals 0. And y minus 3x equals 4. Okay? What we're looking for is one value of x, one value of y. So what do? What happens when you add those two? What do you get? Well, what's y plus y? 2y. What's negative x plus negative 3x? Negative 4x equals 4. What's the problem? Nothing was eliminated. And our whole goal is to eliminate at least one of the variables so that we can solve for the other variable. So that didn't work. What do we have to do? Yes?
Multiply one of them by a negative 1.
Okay, multiply one of them by negative 1. So which one are you trying to get rid of? Are you trying to get one of the y's or the x's?
Y.
The y's. Why? Just kidding. Okay. So let's multiply this by a negative 1. This becomes negative y. This becomes negative positive x. That's 0. Now let's try these two equations, and sure enough, good. That's 0. Negative 2x equals 4. X equals minus 2. Put the minus 2 up here, find the y. Very good. What else? What if I want to keep my y's? What if I want to keep this y up here and I want to get rid of the x's? How can I get rid of the x's? What do you think? Multiply which one? By what? Okay, if I multiply by a positive 3, I'd have 3y minus 3x equals 0, right? But that's the same, negative 3x and a negative 3x, so what do I have to do now? Make one of them negative all the way across. So I should have multiplied by a negative 3, that'd be this, right? Now this becomes 0, I got negative 2y equals 4, y equals negative 2. Either way will work. You can either solve for the x, you can solve for the y, and sometimes when you look at the problem right away, you'll say, ooh, this is the easiest way. Isn't that what we usually look for? Most of us. This is the easiest way, and do that way. But you only did that out of doing a lot of these problems by experience. Okay, let's try one more. Y equals negative x minus 3, and y equals 2x plus 3. Which one do you think would be the easiest to get rid of? The what? Well, you know, we could get rid of the 3's easily, but we'd have 2 variables. Good try. Yes?
The x's.
Okay, how would you get rid of the x's?
Since one's negative,
One's negative, one's a positive. Multiply through by what? 2. Good. So we'll make this 2. And we'll make this negative 2. And this would become what? 6. We don't have to change any signs. And so now we have negative 3 over here. We have 3y here. Y equals negative 1. Very good. Okay? Could we have gotten rid of the y's that time? Boy, I hope I remember what the original problem was. Was that like that? Is that the original problem? Okay. How do we get rid of the y's?
multiply by -1.
Yeah, just multiply either one by negative 1. Which one do you want to multiply first? Top one. Make that negative, make that positive, because everything gets multiplied by negative 1. So this becomes our 0. 0 equals 3x plus 6. Got to put the 3x over here, or the 6, whichever one you want. X equals negative 2. So either way it will work. And once you find the one solution, you pop this back up into here, and you find the other solution. Okay? There you go. So now you know how to find simultaneous equations 3 ways.